Okay, so in this video we're going to be having a look at the Higher Paper 3 topics on the Edexcel Advanced Information List. Now again, you can access this checklist that you can see on the screen. That's in the top of the description, so feel free to download that, print it off and use it as you like. Now throughout this video we're going to have a look at one type of question on each of these topics here, but of course just like the previous videos you do need to make sure that you are doing further revision and having a look at your notes and making sure that you're listening to what your teachers are asking you to do. I will only be going over one type of each question, so of course there could be multiple different types of questions on that particular topic. Now of course if there is a particular topic that you are not so sure on, that should be your priority for revision, and as I will show you in just a second, if this is the first time you're visiting this video, I'll show you how you can access all of those in this video and everything hopefully that you need in order to pass and get through this GCSE. So let's just have a look at that now and I'll show you how this all works. So when you are on this video, if you click into the description, which you can see on the right hand side just here, just at the top there it says the Higher and Foundation checklist. Now no matter which exam board you're doing, they're all in there, so you can access that, download whichever one you need for Higher or Foundation, and they will all be available to you. Just below that it says download the free practice booklet for these videos. Now if you click on that, you can also download the practice booklet, which you can print off and work through all these questions either on your own, or you can go along through the video with me and answering the questions on the booklet. All of the papers are also available just below that, and if you continue scrolling down you'll see that throughout the video next to each topic there is a link to a full lesson on that topic. Now that's going to be really important because obviously, just for example, on the algebraic fractions question there, I'm going to go over a question on simplifying an algebraic fraction, but within the video I also go over adding, subtracting, multiplying and dividing algebraic fractions, and you do need to make sure you have a look at all of them. Now throughout the video, if you click, obviously once it's paused, just in the bottom left of the video you can click on the chapters. And if you click on that, you can scroll through the video, you can have a look at any of the topics that I'm going over. They're all listed there, they're all in order of the booklet as well, so you can obviously just scroll through and find the questions if you need to just go over one particular answer. Now again, if you click into the description, have a look and click on that download the free practice booklet, it will open up this link and you'll be able to access whichever paper you want. So for that particular video, I click on paper 1 Higher, and it will open up this booklet that you can scroll through, you can download it, you can print it off, and you can work through these questions. So that's all available for you, that's all for free, you can download that, use it as you want. Obviously make sure that you let people know so that other people get the access to this as well, and don't forget, if this is useful and helpful, don't forget to like the video, don't forget to subscribe to the channel for all the upcoming videos for all of these topics and everything that's going to be going towards the new GCSE. And we've got a lot to get through, so let's get started. Okay, here we go. So 3 squared times 3 to the power of 5 all over 3 to the power of 3, and it wants us to write it again as a power of 3. So all the base numbers are the same, they're all 3's, and we're going to have to deal with this in a slightly different way because we've got a multiplication on the top and then a division to deal with. So whenever I've got a question like this, I just like to tidy up whatever's on the top before we have a look at what's on the bottom. So let's tidy up what's on the top. We have 3 squared times 3 to the power of 5, so we can add the powers there, so we get 3 to the power of 7 on the top, although we're still dividing that by 3 to the power of 3. But now we've tidied up the top, we can apply that second rule and we can subtract the powers. So 7 take away 3 gives us 3 to the power of 4 as our final answer there. Okay, we're going to have a look at one more. Okay, slightly different question here. It says write down the value of, and then we've got 5 to the power of 7 times 5 to the power of negative 3 all divided by 5 squared. So write down the value. Now value doesn't mean to write it as a power, so we're not going to have it as something like 5 to the power of something. We don't know what that power is, but instead we're going to write down what the actual value is. So if it came out as 5 cubed, for example, we wouldn't write it as 5 cubed, we'd work out 5 times 5 times 5, which would be 125. So 125 would be the value if this question did come out as 5 cubed, but let's have a look and see what it actually comes out as. So we've got a little bit of extra stuff going on here as well. You might have noticed there's a negative power on the top there, negative 3, but we're going to just deal with it in the same way as we would with normal numbers here. So on the top I'm going to tidy that up, and we've got 5 to the power of, I'm going to do the working out to the side here because we're going to add these powers together. Now the first power is 7, and I'm going to add to that the second power, which is negative 3. So I'm just going to follow my normal number rules here. When we've got adding a negative, that's the same as taking away, so we've got 7 take away 3 to do, and 7 take away 3 is 4. So on the top there I'm going to have 5 to the power of 4. Okay, so when you've got negative powers here, don't forget just to write it out as a little sum to the side so you can see what's going on and take that out of your head. And we're going to divide that by 5 squared. And again, now we're doing a division. We've got 5 to the power of 4 on the top, take away 5 to the power of 2, so 4 take away 2, it leaves us with 2. So our final answer there is 5 to the power of 2, but it did say to write down the value of this. So 5 squared, we just need to work that out. 5 squared means 5 times 5, and 5 times 5 is 25. So that is our value there of this 5 squared that we've got. Right, I've got some of these for you to have a go at. Don't forget just to apply your normal rules with your numbers. One thing that could also happen, which I'm not going to go over on this particular one, is we could have had a negative power on the bottom. So let's just think about this to the side, how that would actually work out. Let's just make one up. So something like 5 squared times 5 to the power of 4. And let's imagine we have 5 to the power of negative 3 on the bottom. Now we'd still tidy up the top. We'd get 5 to the power of 6 on the top, divided by 5 to the power of negative 3 on the bottom. Now this time when we subtract, the sum we'll do for that power on the bottom is the 6 on the top, and we're going to take away the power on the bottom, which is negative 3. So just thinking about that to the side, 6 take away negative 3 becomes a plus here, and 6 plus 3 is 9. So actually we would end up with 5 to the power of 9 for this particular one. Okay, so just be thinking about your numbers depending on what comes up on the top and the bottom in those powers and where those negative powers are, if they are there. Now in this question we're given a formula, and that is V equals S over T. And then it gives us some values. It says that S is 2.34 correct to 2 decimal places, and T is 1.3 correct to 1 decimal place. Then it says work out the lower bound for V and give your answer to 2 decimal places. So we are going to be using a calculator for this. This is a calculator topic, so make sure you've got a calculator on hand as we go along. Now as soon as you see this information here that says something's been rounded to a certain amount of decimal places, straight away we need to write the error intervals. So for this one here, 2.34 correct to 2 decimal places, if I write the error interval for that, we have as our upper bound 2.345, and our lower bound, drop that down, it'd be 2.335. Okay, and there's our lower and our upper bound of S. Next we're going to do exactly the same for this T here, so we'll do the lower and the upper bound of T. In the upper bound we add the 5 on its 1 decimal place, so 1.35, and the lower bound will drop it down 1.25. And there we go. And when it comes to exam questions, you've bagged yourself a few marks here getting the bounds down. So even if you don't move any further with this, which I'm hoping you will do after this video, they are the essentials there to make sure that you grab yourself those 1 or 2 marks for getting down the bounds. Now it says it wants us to work out the lower bound for V. Now in this formula here, and we're going to be looking at all of these where we've got fractions within them. It's a little bit easier if there are no fractions in there. But if we're trying to find out the lower bound of V, or basically the lowest possible answer for V, we need to think about how we're going to approach that fraction in that division. Now we've got 2 options here. We could do any, well, we've got lots of options, but we could do any combination of bounds. So we need to think, how are we going to get the lowest possible answer? Now if we think just logically about some numbers, let's just pick the numbers 10 and 2. If I do 10 divided by 2, or the other way around, 2 divided by 10, which one gives me the smallest answer? Well, 10 divided by 2 is 5. Oh, it's 5. And 2 divided by 10 is 1/5, or 0.2. So obviously this one here, 2 over 10, gives me the smallest answer. And I'm just thinking about the logic here about numbers, in that if we want the smallest possible answer, we want the smallest possible number on the top and the biggest possible number on the bottom. Okay, so this is obviously just a random selection of numbers here, but just thinking about how we get small numbers, and that's what we want, the lower bound. So to get the lower bound, we want to do the smallest number on top, so the lower bound of S, and we want to divide it by the biggest number on the bottom, so the upper bound of T. Obviously the lower bound of S, because S is on the top of the fraction, and the upper bound of T, because T is on the bottom of the fraction there. So I'm just picking those from our actual formula that we've been given. So I want the lower bound of S, and if we highlight that, S is here, here's our lower bound of S, 2.335, and our upper bound of T is 1.35. So I'm going to write that working out down. So we have 2.335 and we're going to divide that by 1.35. Right, so if I type that into the calculator, let's see what we get. 2.335 on the top, divide it by 1.35, and we get an answer. And our answer comes out as 1.7296, and there's a recurring decimal above the 2 and the 6 there. And it wants us to round our answer to 2 decimal places, so always make sure you write down the full answer first. And now we're going to look at rounding it. So if I chop it after the second decimal there, that gives us 1.7. It's a 9 after the 2, so that rounds it up to a 3, so it's 1.73, and there's our final answer, 1.73. Right, okay, let's have a look at another one. Just remember with both of these, you write down all your error intervals, then if it is involving a fraction, you just need to think about how you get the lowest or the biggest bound there, the lower or the upper bound in actual use of a fraction. But we'll have a look at the other way around and see what we get this time. Okay, so a train takes 3 hours to complete a journey, correct to the nearest 5 minutes. The length of the journey is 260 miles, correct to the nearest 10 miles. By considering bounds, work out the average speed of the train. Give a reason for your answer. Now this isn't very nice, not a nice question at all, there's a lot going on here. Our first thing is that we have to work out speed. So our formula for speed equals distance divided by time. Okay, so we have to write down the formula for this one, so obviously it requires you to know that. Now we've got our fraction scenario going on, and we've got different elements going on in the question here. So we've got the distance, which is the length here, so we've got 260 miles. Let's highlight that, that's our distance. And we've also been given a time, so 3 hours, and that's to the nearest 5 minutes. So if we actually start to write these down, let's do the error interval of D, so for the distance. Right, so I'm going to put D there just to remind myself that's the one. So the distance there is 260 to the nearest 10. Now when it's to the nearest 10, remember that's the same as 2 significant figures in this time. So to the nearest 10 could be 5 miles above and 5 miles below. So our upper bound is 265 and our lower bound is 255. Again, do make sure you check out that video on error intervals if you're unsure on this one. But 255 and 265 are my bounds for the distance. Now I'm going to have a look at the error interval for the time. Now this is quite a nasty one here, okay, because it's given us the time in hours and it's given us the error interval in minutes, and it says the nearest 5 minutes. So in order to get this, let's turn 3 hours into minutes. So 3 hours into minutes is 3 times 60, 60 minutes in an hour, which is 180 minutes. So the time it takes is 180 minutes. Now it's to the nearest 5. Now remember, to get the upper and lower bound to the nearest 5, you add 2.5 on and take away 2.5 minutes for the lower one. So 180 add 2.5 becomes 182.5, and taking 2.5 away would become 177.5. Okay, so just be very careful when you're adding 2.5 and taking 2.5 away there. Now that's not going to be very nice, because we're typically going to want our answers in miles per hour. Now if we're going to do miles per hour, we need to turn this back into hours. So that's not particularly nasty, it's just that we have to remember to do this. So dividing them both by 60, we'll turn them back into miles per hour. And if we do that, 177.5 divided by 60, if I can type that in correctly, 177.5 divided by 60 doesn't give us the nicest of decimals, it gives us 2.958 and a recurring 3. But there we go, it's back into hours. And for the one at the end here, 182.5 divided by 60, again doesn't give us the nicest of decimals, it gives us 3.0416 with a recurring 6, there we go. And that is our time back into hours. That'd be okay if we could give our answer in miles per minute, we could just leave it in minutes, but in order to do this we do need our answer back into hours there. So now we've got our error intervals done, we still need to actually go about using this formula. So we've got speed is distance over time. Now let's move that out of the way, let's put that up here. Okay, and we're going to have a look at working this out. So to get our upper bound, which we can work out first, to get our upper bound, let's have a look. What do we do for upper bound? We do the distance upper bound, so the upper bound of D, and divide it by the lower bound of T, the time, which is there, 2.9583. So let's just write that in. That was the upper bound divided by the lower bound. Thinking about speed is distance over time. So we've got 265, and we need to divide that by 2.958 recurring 3. I'm going to write down what that actually equals. Okay, so in order to get that decimal, what I'm going to do on my calculator, I'm going to type in 177.5 divided by 60 again, so that I have that decimal on my calculator screen. Okay, I'm just talking about this one just here, so I didn't have to type it back in. And now I'm going to type in 265 divided by answer, so that it does, so I don't have to try and type in that recurring decimal. There we go. And if I type that in, we get 89.57746. And then we've got a few more decimals, 4788. I'm going to leave it there because it tends not to go beyond these. Again, if I find that it does, I'm just going to have to retype this all back in again. Hopefully it doesn't though. Now to work out the lower bound. So for the lower bound, that is not an L. There we go. To work out the lower bound, we've got to do the lower bound. That is not, for some reason I keep wanting to write in the upper bound. We have to do the lower bound and divide it by the upper bound. Okay, so picking those numbers out nice and carefully, we've got the lower bound of the distance, 255, divided by the upper bound of the speed of the time there. Right, and typing those in, what do we get? So the lower bound there is 255, divided by 3.0416. Right, and let's type that in. Right, let's get rid of this little miles per hour thing, I don't actually want that there. Right, so typing this into the calculator, and again what I'm going to do is I'm going to retype this calculation in here, 182.5 divided by 60, so I've got that decimal on my screen. So 182.5 divided by 60, so I've got 3.0146 recurring on my calculator, and now I can do 255 divided by answer. And I'm going to write that down, let's have a look, that gives me 83.83 561, and there's a recurring dot above the 8, but I can't write them all down. There we go. Okay, so let's have a look at this. Now this is a very bizarre one, because if you have a look already, you can already see that there's no amount of decimal places that are going around, because we've got 89.5 and we've got 83.8, so they are very far away from each other. So this is going to be a very, very bizarre question here. So if this scenario did arise, and you'd hope, and it is usually the case, that they are quite close together and they do round to a nice amount of decimals, but it could be absolutely anything. So for this particular question here, we are going to have to think about how we're going to round it. Now even to one significant figure here, they don't round to the same amount. Well, that one on the top there rounds to 90, and the one on the bottom rounds to 80. So that's absolutely useless, so that's not going to work. So the only way that we could actually round this to the same is if we round it to the nearest 100. Okay, so the average speed we're going to have to round to the nearest 100, which seems a bit odd because it's actually quite a distance away from that, but they both round to 100 to the nearest 100, and that is the most accurate that we could actually do this question. So I would have to say 100 miles per hour. There we go, and that would be to the nearest 100. There we go. Now, it's very rare that a question will do this, okay, because it just doesn't make for a very good question, but that's not to say that it can be ruled out. Okay, it could actually happen. You could have a question like this where the only way it rounds is to the nearest 100 and it's quite a distance away, and if that does happen, then at least you know that you are able to do that. But to be honest, the majority of the questions do actually round to the nearest like decimal or significant figure or something like that, but that's not to say that it couldn't happen. So it's a good question obviously to bring up here. Okay, so this question says Jeff is choosing a shrub and a rose tree for his garden. At the garden centre there are 17 different types of shrubs and some rose trees. Okay, so we don't know how many rose trees. Jeff says there are 215 different ways to choose one shrub and one rose tree. Could Jeff be correct? And you must show how you get your answer. Now if we knew how many rose trees there were, we would do 17 and we would multiply it by that number. Let's call that number x. So 17 times x, whatever that would be, and that would give us the answer 215 if Jeff is correct here. Now basically all we need to figure out is there a number that you can times 17 by to get 215, and if there is, then obviously Jeff can be correct. If there isn't, then he can't be correct there, it can't be possible. So if we think about this in reverse, then if we just do 215 and divide it by 17, I'll do that on the calculator, see what we get. 215 divided by 17, and we get a decimal, we get 12.64 and a lot more decimals there, but 12.64. The important thing here is that it's not a whole number. So if it was 12, for example, 17 times 12, that'd give us 204. That could be a possible amount, 204, or maybe 17 times 13, which would give us 221. So they would both be possible combinations, but this option here of having 215 possible combinations is not correct, so no. Okay, because there is no number that multiplies by 17 to make 215. So just thinking about this in reverse with in terms of the total there, and actually is that a possible total? Let's have a look at one more of these. Okay, so something a little bit different here. We've got two different questions. It says there are 3 dials on a combination lock. Each dial can be set to one of the numbers 1, 2, 3, 4 or 5. The 3-digit number 553, which is on the diagram over here, is one way that it can be set. So we can see that there, 553. It says work out the number of different 3-digit numbers that can be set for the combination lock. So it just says different 3-digit numbers. So that can be any amount of numbers on each lock. Let's have a look, different 3-digit numbers. We could have 111, 112. We can have any sort of different combination there. It doesn't say anything about not allowing repeating numbers in each one. So we could have 111, that'd be fine. Okay, obviously not worrying about the fact that there's 553 up there. That's just one of the options that we could have within this. But in terms of the different 3-digit numbers, what could we have? Now part B is slightly different. It says how many of the possible 3-digit numbers have 3 different digits. Okay, so 3 different digits there. And that would mean that we couldn't have 111 anymore. We could only have something with different digits. So 123 would be fine, but 111 would not be allowed because that's got the same digits within it. So 2 different questions there. So what I would say is pause the video, have a go, see what you get for these answers, and we'll go over the answers in a sec. Okay, so this first one, it says work out the number of different 3-digit numbers. So we just need to think about how many options we have on each pick. So on the first pick, we've got 5 different numbers to choose from, so we've got 5 options there. On the second pick, it doesn't matter what we choose, we can choose any of those 5 numbers again, so we've got 5 numbers again. And on the third pick, again, it doesn't matter what number we choose, so we've just got 5 options again. So it's 5 times 5 times 5, and that would give us 125 different options there of different combinations that we can set on this padlock. And there we go, there's our first answer. Now the second one's slightly different. It says how many of the possible 3-digit numbers have 3 different digits. So this means on the first pick, look, we've got 5 options, but on the next pick, let's imagine we've picked a 1, we cannot have a 1 again, so we can have a 2, 3, 4 or 5. So we've only got 4 options to pick from now, so that would be times 4. And then let's imagine we've picked a 1 and a 2. We can no longer have a 1 and a 2, so we can only pick a 3, 4 or 5. So we've only got 3 options now on that third pick, so that would be 3 options. So 5 times 4 times 3 gives us a total of 60 options if we want to make sure we have all different digits there. Right, there we go, and that is our final answer on this last question. Okay, so we've got lots of pieces going on here, so I just need to be really, really careful that I underline all the pieces that I'm looking for or circling them, just being nice and careful. So let's have a look at these x squared pieces. We've got a 3x squared there plus a 2x squared there. So in total, 3 plus 2 gives us 5 lots of x squared. Moving on to the next piece, we can look at the x's next, all the numbers. In fact, it's a 5 there, so let's just look at the 5. So we've got -5 and -1. So -5 take away 1 is -6. There we go, and there's the numbers done. And let's have a look at these final bits, which are an x. We've got -4x plus 7x. So -4 add 7 is +3. So we'd have +3x. There we go, and that's simplified. Again, we could have done that in any order, so we could have any rearrangement of this. If I'd have done the x squared pieces first, like the same way, but then done the x, I'd have 5x squared, and then I'd have the +3x, and then the -6. So they can be in any order there as long as the symbols are correct in front of them. So we've got 2 brackets here. It says expand and simplify. So we've got the first bracket here with the 3 at the front, and we've got the second bracket here with the 5 at the front. So I'm just going to expand them separately and see what we get. So looking at this first bracket to start with, the 3 brackets 2x plus 5. If we expand this out, so timesing both those pieces by 3, 3 lots of the 2x gives us 6x, and 3 lots of the 5 gives us 15, and that's a plus there, so keeping the symbol the same, +5. Now looking at this second bracket, which we've got a 5 at the front. Now it's +5 at the front, +5, so we're going to expand them both by +5. So 5 times x is +5x, so +5x, and +5 times -2 is -10. So be very, very careful with the symbols here. That is a -2, so that'll make -10. And all we have to do is now simplify this, so tidying it up. So we have a 6x and a 5x, a +5x, and 6 plus 5 is 11, so we have 11x's. and we have positive 5 and negative 10, and 5 take away 10 is negative 5, so 11x minus 5, and that's your final answer, and that's it simplified. Okay, so work out the value of 2x squared minus 3x when x is negative 4. Let's see what we get here. So we have 2 lots of negative 4 squared, take away 3 lots of negative 4. And let's just work through this nice and slow. So negative 4 squared becomes 16, negative 4 times negative 4. So let's just rewrite that. We have 2 lots of 16, take away 3 lots of negative 4, and 3 lots of negative 4 is negative 12, so take away, let's just write it out slowly to start with. Let's just do 3 lots of negative 4, and now we can get rid of these brackets on this next step. So 2 lots of 16 is 32, and we're going to take away 3 lots of negative 4, which is negative 12. There we go, so we've got our double negative going on again, so that's going to be a plus. So we have 32 plus 12, and 32 plus 12 is 44. There we go, seems like a lot of steps there. Some of them you might be able to do in your head, but I think it's really important just to make sure that you keep it all really nice and clear so you don't make any mistakes when you're doing these sorts of questions. Now it says make x a subject. Now if you have a look, there's an x on both sides. So the equal sign here, we've got an x here and an x here. Now when this happens, there's only one process that we can do to turn 2 of these letters into 1, and that's going to be factorising at some point. Now in order to do that, we need to get the x pieces next to each other. Now these can be a little bit annoying because there's 2 different ways of doing it, and that means that obviously we can get the x pieces on the left hand side, or we can get the x pieces on the right hand side. And what I'm going to do is I'm just going to avoid having any negatives in front of pieces, and I'm just going to do it in one particular way, but there are 2 ways of doing these. So what I'm going to do is, for this particular question, I'm going to move the x pieces to the right hand side, and we'll have a look at some different ways. Now in order to do that, I need to get rid of this minus 3z on the right. So first things first, I'm going to add 3z to both sides, so add 3z. Now once I've done that, we've got 3x plus y plus 3z, and that now equals zx. Okay, so that's the first step done. Now in order to get all the x's next to each other, I need to get that 3x onto the other side. So I'm going to have to minus 3x from both sides, because that's a positive 3x. And then I'll have all my x's on the right hand side. Okay, so once we've done that, we're left with, on the left, y plus 3z. And that now equals zx minus 3x. Now all the x's are next to each other, we can do this final step now. I can actually just factorise this right hand side here. So if I factorise that by x, taking an x out of the brackets, on the right, let's write what we've got on the left first. We've got y plus 3z on the left, and on the right we will get x brackets z minus 3. And there we go, now I've just got 1x in my formula here. So the final step now to finish this off is to divide both sides by this bracket. Okay, and once I divide both sides by that bracket, x will be isolated on its own, and all we've got to do is stick that underneath what's on the left there. So we have y plus 3z on the top, divided by that bracket, which is z minus 3, and that all equals x. And again, we could rewrite that if we wanted, but that is how we rearrange some of these harder formulas here, and we are going to have to go through that process of factorising for all of them. Okay, so let's have a look at another one. Okay, so another similar question, but we've got a square root over it this time. So the first thing we have to do to unlock that fraction is to square both sides. So if we square both sides to start with, we get y squared equals, and then what's written underneath there, so x plus 2 over x minus p. Now, same as the last question now, we need to unlock this fraction, so we need to get rid of that by timesing both sides by x minus p. And if we do that, that opens up a single bracket on the left. So we have y squared brackets x minus p equals x plus 2. And again, we're going to need to get rid of that bracket now, so let's get rid of that bracket. So let's have a go. Xy squared, or y squared x, but xy squared minus py squared equals x plus 2. Now we can start getting the x's on the same side. So I'm going to add the py squared over to get rid of that minus. So xy squared equals x plus 2 plus py squared. Now we can minus the x over. So xy squared minus x equals 2 plus py squared. And then we can actually finish this off now by factorising this left hand side. So we get x brackets y squared minus 1, because it's 1x, equals 2 plus py squared. And then we can finish this off just like all the others, dividing by that bracket. So x equals 2 plus py squared over y squared minus 1. And there's our final answer there. So we've got three brackets here, x plus 3, x plus 4 and x plus 1. Now when we're expanding a triple bracket, very similar to when we're expanding a double bracket in the process that I use, but it just tends to be a little bit longer, it tends to get a little bit messier, and you just got to keep it all really nice and tidy and just be careful with what you're doing. Now what we're going to do is we're just going to focus on two of them to start with, and it doesn't matter which two you pick. I tend to pick the two that look the hardest to expand, and for me that's going to be these first two here. So what I'm going to do is I'm just going to expand those two. I'm going to forget about the x plus 1 for the moment. So I'm just going to rewrite that, x plus 3 and x plus 4. And I'm just going to expand this just like I did with my double brackets. So x times x gives us x squared, x times 4 gives us 4x, x times 3 gives us 3x, and 3 times 4 gives us 12. And again, just make sure you tidy this up now before looking at the next one. So we'll tidy those up. We get x squared plus 4x, plus 7x plus 12. There you go, once it's all tidied up. Now we've done that, we just want to reintroduce that final bracket that we had in the question there, the x plus 1. Okay, so let's stick all of this in a bracket, and we're going to times that by the x plus 1. There we go. Now at this point it does start to get a little bit messy, so make sure you've left yourself enough space. I'm just going to move this out of the way. Let's move it down here. Give ourselves a little bit more space because it does start to get a little bit messy here. So, starting with the x squared piece, I'm going to times that by both the pieces in the x plus 1 bracket. Then I'm going to move on to the 7x, then I'm going to move on to the 12, and I'm just going to keep it all really nice and tidy because it does get a bit messy here. So x squared times x gives us x cubed. And there we go, there's the introduction of the cubed here, which is why these are called cubics as well. X squared times 1 gives us 1x squared. I won't put the 1 in, we'll just write x squared. And then I need to move on to the 7x. Now it is going to start to get a bit messy, so I'm going to try and use different colours here just to separate it out a bit. Let's go with the green. So 7x now times x. There we go, 7x times x gives us 7x squared. It's positive, so plus 7x squared. Then we've got the 7x times the 1 lot of 7x is just 7x. And now I'm going to move on to the 12. So moving on to that to finish it off, we've got 12 times x, which gives us 12x. And then 12 times the 1, which gives us 12. There we go. And now all we need to do is collect the like terms together. So if we have a look, we've got the x cubed at the start, that's on its own, but we've got the 2x squared pieces there and also these two x pieces here, so we just need to tidy them all up together. So 1x cubed leaves us with x cubed. We've got the 1x squared and the 7x squared, and that together makes 8x squared. We've got the 7x and the 12x, and that gives us 19x. And then the 12 at the end. And that's it, finished up, expanded, simplified. It's a little bit messy, there's a lot going on there, you do have to keep this really nice and tidy, but that is the end of that question there. Okay, so we've got larger coefficients of x here, we've got the 2x and the 3x, and I'm going to start by expanding these two. So let's write that out. We've got 2x plus 3 and 3x minus 2. So we know we're going to get the 6x squared here when we do the first two, so 2x times 3x gives us the 6x squared. And let's have a look at those middle two. So we get minus 4x plus 9x and those middle two. So minus 4 plus 9 gives us 5x. So we're going to have plus 5x, minus 4 plus 9. And then we're going to get minus 6 at the end. There we go. So just save you a little bit of time if you can do this. And let's stick that in a bracket. And we're going to multiply it by the x minus 4. There we go. We can do it all from here now. So just following the same process as before. 6x squared times x gives us 6x cubed. 6x squared times negative 4 is negative 24x squared. And then moving on to the underneath. 5x times x gives us plus 5x squared. And 5x times negative 4 gives us negative 20x. and then onto the negative 6 to finish it off. Negative 6 times x is negative 6x, and negative 6 times negative 4 is positive 24. And then we just need to tidy all this up again. So we've got the x squareds there and the x pieces here, and let's just rewrite all that nice and tidy. So 6x cubed, negative 24 add 5 is negative 19, so negative 19x squared. Negative 20 take away 6 is negative 26, so negative 26x, and then plus 24 at the end. And there's how to do that one. So keep it all really nice and tidy, expand whichever two you want to start with, tidy it up with your third bracket at the end once it's been simplified, and then just go step by step really nice and carefully before you tidy it all up at the end. And remember what your answer should look like. You will get these cubes, the squareds, the x, the numbers. Sometimes they might cancel each other out, but in none of these they have. Okay. So this is a quadratic as well, but there's no x piece in the middle. Okay, so there's no x piece in the middle, but we can find the factors of 100 and just think what they are. There's quite a lot of them. We could have 1 and 100, we could have 2 and 50, we could have 4 and 25, there's 5 and 20, and there's 10 and 10, so 10 times 10. Now because there's no piece in the middle, it means that in the brackets, and let's just write them out, the numbers that go into the brackets must have to cancel each other out to cancel out that x piece in the middle. So this has got a special one. It's called a difference of two squares, and it's because the numbers that go in there are the same, because they have to cancel each other out. So in order to get 0, if you look at all these pairings here, there's only one pair that allows you to get 0, and that is if we have 10, positive 10, and take away 10, and that gives us 0. So it's just plus 10 and minus 10. There you go. And if you expand that out, you would get x squared, you'd get minus 10x, you'd get then plus 10x, and you'd get your minus 100 at the end there. And these two pieces in the middle would cancel each other out, and we'd get x squared minus 100. So there's only so many of these questions that you can get. The little hint is this number at the end here is always going to be a square number. Okay, so if you see a square number there, you know that it's going to be one of these difference of two squares, and just double check it just to make sure. Okay, so when it comes to algebraic fractions, there's obviously quite a lot of things that we could look at. We could look at adding and subtracting them, multiplying and dividing, but for this question we're going to have a look at simplifying one where we have a difference of two squares on the bottom. Throughout the video obviously we will have a look at a few other elements of algebraic fractions within other topics, but for this question we're just going to have a look at simplifying. So when we are simplifying an algebraic fraction, we need to factorise the top and the bottom. Now if you know these quite well, the bottom there is a difference of two squares, and that's much easier for us to factorise than on the top. Now when we have a difference of two squares, we just look at that squared number, which is 16, or that square number, and when we factorise that, the square root of 16 is 4, so in our brackets it is going to be 4 and 4. Of course, with a difference of two squares, we just have different signs. We have plus 4 and minus 4. That can be written in either order as well, which is why there's no x piece in the middle of that quadratic, because the plus 4x and minus 4x cancel each other out. Now this gives us a hint for what's on the top, because when we factorise what's on the top, obviously we have a coefficient of x bigger than 1. We've got a 2x squared, so that means in one of our brackets we'll have a 2x, and in the other bracket we're just going to have 1x. Now the fact that there's a 4 at the end, we have options. We have 1 and 4 or 2 and 2, but because we've already done the bottom, we know it's going to have to be 1 and 4. Otherwise it's not going to actually simplify, because the 2 wouldn't match either of the 4's on the denominator. So it has to be 1 and 4, and if we use a bit of logic, 4 has to go into this bracket here with just the x in. Now we just need to figure out whether that's going to be the plus or the minus. So if we think about the 7 in the middle, how would we make 7 using 1 and 4? Well, we want the 4 to double, which is why it's in the other bracket. And we want to make negative 7, so we want that to be negative 8 when we multiply that out, so minus 4. And that means we want the other one to be plus 1, which would allow it to be negative 8, add 1, which would be negative 7 in the middle. And those two numbers do multiply to make negative 4. So now we've factorised it, we can cancel off any common brackets. So we've got the x minus 4 and the x minus 4. They'll both cancel out, and then we're just going to write what's left, and you can leave the brackets if you want. I tend to get rid of them. So we've got 2x plus 1 over, and that's going to be x plus 4 on the bottom. And there we go, that'll be our final answer there, and that is our simplified algebraic fraction. So I'm going to label it equation 1 and 2. And just take a quick thought here that these symbols are the same, aren't they? They're both a negative there, so we're going to apply our same sign subtract. We just need to make sure those coefficients of y are the same again. So similar to question 1 here, we've got a 5 and a 2, so we can make that equal 10. So I'm going to times the first equation by 2 to make sure that 5y becomes 10, and the second equation by 5. I'm going to write them to the side again. So 3x times 2 is 6x, so we have 6x minus 10y equals, and then negative 31 times 2 is negative 62. So negative 62. And then times in the second equation. So 4x becomes 20x minus 10y again. And that equals negative 18 times 5 is negative 90. Again, don't forget, you can take your time to work out these multiplications. Just be very careful with them and make sure you get them right. So we've got the same signs, so we're going to subtract them. Okay, so I'm going to put the minus in. Now I'm going to do the bottom one, and I'm going to subtract the top one. I could do it the other way around if I want, but I want to get a positive 14x down here rather than a negative. It's doing 6 take away 20, so I'm going to do the 20x take away the 6x. So the bottom one, 20x take away 6x is 14x. The negative 10y's disappear, remember that's why we're doing it, negative 10y take away a negative 10y. But now I've got to work out negative 90 take away negative 62. And when you've got negatives in here, I always just write the working out down to the side, so negative 90 take away negative 62. Okay, so remembering obviously when we've got a double negative here, that's going to turn into a plus. So I've got to do negative 90 add 62. Okay, if you've got a calculator, if you haven't, just be very, very careful when you're doing this, but negative 90 add 62 gives us a value of negative 28. Okay, and that equals negative 28. Okay, so let's just put that value in. 14x equals negative 28. And then dividing by 14, 14 fits into 28 twice, so it fits into negative 28. We have negative 2 as our answer, so x is negative 2. And then again, just subbing that into one of these equations. They've both got a negative in, neither of them look particularly nice. So let's just sub it into equation 1 again. So sub x equals negative 2 into 1. And let's just write this out very nice and carefully. And if you want to, obviously write out your working out here, but we're going to sub it into the 3x part. So 3 lots of negative 2 is negative 6. So negative 6 take away 5y equals negative 31. Just subbing it in there. Add the 6 over to both sides, just like we've done on previous questions, and we get negative 5y equals, and add 6 to negative 31 is negative 25, remembering it's getting closer to 0 there. And then we're going to divide by negative 5. So in this final step, we're dividing by negative 5, which is going to be the same as dividing by 5 over here, but that's obviously going to flip the sign. So we're going to have y equals, and negative 25 divided by negative 5 is just positive 5. So y equals 5. And there's your answer for that one. Okay, so on to the last example, and this is really quite a nasty one. Can't imagine you getting one much harder than this, so let's just have a look at this one. So let's label it equation 1 and 2, and you've probably noticed in equation 2 there we've got this negative 5.5 here, so we're not going to get a very nice answer here, but we'll treat it in exactly the same way. So we're going to get the y coefficient to be 6 here, so with 3 and 2, so let's times the top one by 2, and the bottom one by 3, and we'll rewrite them. So 8x becomes 16x, plus 6y equals 2 times 2 is 4, so 4, times the bottom one by 3, so 9x minus 6y equals negative, and let's times that by 3, we get 16.5. And now we can just go about adding them together because we've got our different signs there, so we're going to add them together. So 16 add 9 is 25, so 25x, and that's going to equal, let's add 4 to negative 16.5, we get negative 12.5. And that's not very nice there, but 12.5 is half of 25. But if we just go about dividing by 25, what would it look like? It would be x equals negative 12.5 over 25. Not very nice at all, but if you do get this scenario and you don't spot that 12.5 is half of 25, you could times the top and bottom by 2 just to remove the decimals, and we would get negative, what would that be, 25 over 50. That's a little bit easier to spot there, that simplifies down to a half. Okay, so that also equals negative a half, which we can write as a decimal if we want as well. We can write it as minus 0.5. Okay, so I'm going to leave it as negative 0.5. It's not a very nice one here, but we get x equals negative 0.5. Now let's sub that in. I'm going to sub it into equation 1 just to avoid using that negative 5.5. I'm going to sub it into 1, let's hope we get a nicer value here. So negative 0.5 into equation 1, we could do that working out to the side. You've got 8 lots of negative 0.5. Now 8 lots of a half is 4, so 8 lots of negative a half is going to be negative 4. So we get negative 4, add 3y equals 2. Add 4 to both sides, so add this 4, and you get 3y equals 6, and then dividing by 3, you get y equals 2 as your final answer there. So not very nice, but if you do get horrible values like this, I mean, practice with your calculator. It could be non-calculator or calculator, but there's just a way that you can tackle these not so nice simultaneous equations as well. Okay, so solve these simultaneous equations. Now it's a very similar question here, but we've got something slightly different than the second equation, because that second equation there, this x minus y equals 2, doesn't say y or x equals. So we're going to have to rearrange this just to make sure it says y or x equals. There's two ways we can do that. We can make it say x equals, or we can make it say y equals, but we're going to opt for one of the ways. Now, if I want to make it y equals, that's going to be the harder version here, I'll show you why, but if we want to make it x equals, we can just add y to both sides. So if I wanted to say y equals, I'm going to get rid of these in a sec. Let's have a look. So if we want it as x equals, we'll add y to both sides and we'll get 2 plus y, or y plus 2 if I write it the other way around. If I want to make it say y equals, which I can do, it's absolutely fine to do, I will have to move the pieces in 2 steps. So I could add, let's have a look, how could we actually do that? We could add y to the other side like we've done, and then subtract 2. So looking at the equation above, x equals y plus 2, we'll take away 2 from both sides and we get x minus 2 equals y. Now, it doesn't matter which one we actually use here, simply because on the last question I actually looked at solving for y. Let's have a look at solving for x. So I'll use this second one here. So x minus 2 equals y. It is important that you can rearrange it in both ways, but that's just how we would have to arrange it if we wanted it to say x or y equals. So let's go for this second one, x minus 2 equals y. So if I sub that in place of y this time, again taking the same approach as before, y equals x minus 2. So x minus 2 I'm going to put in place of the y there where it says y squared just here. So let's sub that in. So if I sub it in, I get x squared plus, now instead of y I've got this x minus 2, so x minus 2 squared, and that equals 34. Okay, so let's actually expand this. We have the x squared at the start, and now we've got a double bracket. So again, I'm going to skip a step here. Rather than doing the double bracket, I'm just going to expand it, but you can feel free to write it out. So x times x will give us another x squared. We've got minus 2x twice, so minus 4x. And then negative 2 times negative 2 will give us positive 4 at the end, and that equals 34. Right, we can tidy this up. We can join up those x squareds. So we have 2x squared minus 4x plus 4 equals 34, and then again we just need to make this equal 0, so we can subtract the 34 from both sides. So let's do that. Let's subtract 34, so we still have 2x squared minus 4x. Subtracting 34 from 4 gives us negative 30, so there we go, negative 30 minus 30, and now it equals 0, and we can factorise it again. So same process for factorising. Let's think of if we can simplify it first, which we can. We've got a 2, a 4 and a 30 there, so we can divide everything by 2 and we get x squared minus 2x minus 15 equals 0. Right, so we can factorise now. We could have factorised before, but it just makes it a bit easier here for us to factorise. So the factors of 15 we can have, let's have a look, and let's write this in a different colour, 3 and 5, or 1 and 15. And let's think, we want to make negative 2, so positive 3, take away 5, that'll factorise for us. So we have x plus 3 and x minus 5. There we go, and that equals 0. And again we get our two solutions there. So in the x plus 3 bracket we get x equals negative 3, and in the other one we get x equals positive 5. Right, there we go. Now our equation that we created above, this one here, y equals x minus 2, allows us now to just sub that in, these x values, in order to get our y values. So if y equals x minus 2, then when x is negative 3, y equals negative 2, take away that 3. Oh, I've not written that the right way around, let's move that. x minus 2, so negative 3 take away 2, we'd have got the same answer there, but there we go, let's write it the right way around. Negative 3 take away 2, which is negative 5. So there we go, y equals negative 5. And for the one on the right there, we've got y equals, let's get it the right way around this time, 5 take away 2, x minus 2. And 5 take away 2 is 3, so y equals 3. And there we go, we have our two solutions. We've got when x is minus 3, y equals negative 5, which again we can write as a coordinate, minus 3 minus 5 if we need to. And the other one there, we've got when x is 5, y equals 3, which again we can write as a coordinate, x is 5 and y is 3. Right, there we go. So thinking about what we've done there, we are rearranging our second equation if we need to, just to make sure it says x or y equals, substituting it in place of the x or y in the circle equation, expanding it all out, tidying it up, making it equal 0, simplifying if possible if we need to, factorising, solving, and then resubstituting it back in to find our y or our x values depending on what we've solved for. So there's a lot of steps there, a lot going on. Okay, so hopefully you've made some good notes on that. It is quite a nice process question whereby, you know, all of these questions are going to follow a very similar process. Okay, so when we decrease by a percentage, now again, if you were going to do this without a calculator, you'd follow a very similar process to what we talked about at the start. So if we work that out quickly so we can see what the answer is, and then we can check our method using the calculator process. So if we work out 10%, just working out 10% of 80, which is 8, we want double that for 20%, so 20% would be 16, and to decrease by that percentage we would subtract it away from 80, so we would do 80, take away the 16 that it's decreasing by, and that would come out as 64. So we know our answer is going to be 64. Now let's have a look at applying our multiplier method. But again, obviously, if you had a non-calculator method, that's how you'd go about it. So again, if we think about 80 as our original 100%, but this time we're going to decrease it. So we're actually going to chop off 20% of that. So if this is 20% that we're going to decrease it by, and the overall amount was obviously 100%, what percentage is going to be left over? Well, 100% take away 20% would leave us with 80%. So the actual percentage that we're going to have is 80%. And if we're going to multiply to find out 80%, this time we're not going to multiply by a 1-point number, because obviously that would increase it, but we're going to multiply by a 0-point number. And the 0-point number that we're going to multiply by is the decimal version of what's left over. And we have 80% left over. So 80%, if we write that as a decimal, is 0.80, or 0.8, but I'll write it as 0.80. And that's the decimal that we're going to multiply by. So whereas before we added the 20% on, which would have been 1.20, and multiplied by that, this time we're taking the 20% off, which leaves us with 0.80. So that's all we're going to multiply by. So this is a bit of a strange one because it's 80 multiplied by 0.80. But if we do 80 times the 0.8 and work that out on a calculator, that gives us the answer 64. And there we go, we've got our match and we know that we've done the correct method. So our answer is 64 and our multiplier in this case was 0.8. So again, you've also figured out something else hopefully in this, and that is if you just want to work out a percentage of an amount by using a multiplier method, you can do it just like this. We've just seen that to work out 80%, we just times by 0.8. So although we're going to be using this for decreasing, you've also now got a method for working out percentages with a calculator. For example, if we wanted to work out 20% of a number, we could multiply by 0.2. If we wanted to work out something like 34% of a number, you could multiply by 0.34. Okay, so there we go. Another method that you can use for working out percentages of an amount, but let's have a look at another question before you have a go. Okay, so looking at a single digit percentage. Now we're going to decrease here by 4%. So if we want to know what percentage is left over, well, if we take away 4% from our original 100%, we would be left with 96%. So if we're going to decrease something by 4%, we actually are working out 96% of that number. And 96% as a decimal can be written as 0.96. So that is our multiplier that we're going to multiply by. So nice and easy, we get 240 on your calculator, multiply it by 0.96, and if we type that in, 240 times 0.96, the answer comes out as 230.4. And there we go, and that's our final answer. So to work out a percentage decrease, we figure out what percentage will be left over once that has been taken away, and then multiply by that decimal version, which we call a multiplier. Okay, so this question says, Amy buys a new car for £18,000. Each year the car depreciates by 12%. How much will the car be worth at the end of 3 years? And obviously we could do this without a calculator, but we're going to have a look at doing some calculator methods here. So obviously the original value, in terms of a percentage, is 100%. Now if it loses 12%, so let's just say, okay, well we lose 12%, what percentage are we actually left with? And 100 take away 12 is 88%. Now there's actually something we can do here, because if it's going to be 88% of its value each year, there's something we can just times by straight away on the calculator, and it's the decimal version of 88%. And the decimal version of 88% is 0.88. And straight away, if we just times by 0.88, it will actually take away 12% for us. I can do that on the calculator, 18,000 times 0.88, and it gives me the answer 15,840. So that would actually just reduce it for me in the first year. And I could just do that 3 times. I could just times by 0.88 and keep on repeating that. Or I can actually do something to speed things up a little bit. And it's very similar to compound interest. And with compound interest, this is something that you add on to this multiplier here to get your 3 years. And it's a power of 3. So if I want to actually do this just 3 times very quickly on the calculator, I can do £18,000. And I can just times it by 0.88, and again I could do it 3 times, or just to speed things up a bit, you can just add a power of 3. Okay, and that will just be the same there. If it was 4 years, you'd put a power of 4, 5 years, you'd put a power of 5. Okay, and it'll just do it that many times for you. So if I type that straight into a calculator, 18,000 times 0.88 to the power of 3, and I get this answer here. I get £12,266.496. And obviously we are talking about money here, so we're going to have to round it to the nearest penny. So a final answer would be £12,266, and I'm just going to follow the normal rules of rounding, so I'll chop it off after the 9, and that rounds up to 50p there. So that 9 rounds up because of the 6, which rounds it up to 50p, so 0.50, and that'd be my final answer there. Again, just rounding to the nearest penny on any of these questions. Okay, so that's how you do it nice and easy on the calculator. Again, just thinking about the percentage, let's just pick a random one. If it depreciated by 23% each year, 100 take away 23 would leave us with 77%, and as a decimal, 77% is 0.77, so I'd times by 0.77. So just something to be thinking about there. Whatever the percentage it depreciates by, you can take that away from 100 and then convert it into your decimal that you're going to want to multiply by. So just a little bit of a quicker way that you can do this rather than having to do all those stages of each year. So this first one says a washing machine has been reduced in a sale by 20%, and then it says the sale price is £512, work out the original cost. And it's that language there that hints to us that this is a reverse percentage, working out the original cost. We're going back into the past. Now when we've got a sale price of 20%, that means something's been reduced in value. So what I do is I draw this little bar out and I think, okay, well I've got 80% and 20%. Okay, so I'm getting a little sale here, and we've got 20%. And we've got the original the new 80% there once we've got our little sale. So what we've got to think here is it gives us this price. It says £512 is the sale price. Now this 20% here, this little bit is always going to be our little discount. Okay, so that's the amount of money that we're getting off. There we go, so that's the discount, and this is the price we pay. Okay, there we go, price we pay. And obviously when it comes to real life, unless there is an absolutely enormous discount on, it's more than likely that we're just getting a little bit there, that 20%. So what we've got to do is read the wording and see what that is. So it says the sale price is £512. So that's the amount of money we're actually going to pay. So if we're going to actually be paying £512, that's the 80%. So straight away I just write down 80% equals £512. There we go, and that's the first bit of the process here. Now all we've got to do is, the thing is, we don't actually want to know 80%, we want to know 100%. We want to know the original cost, the original 100 before that 20% was taken off there. So in order to do that, we've got to figure out what percentage can we turn this into, this 80%, so that we can turn it back into 100. Obviously there is a number that you can times 80% by, but without a calculator it's going to be really hard to work out. Now if we can get it down to 10% or 5%, that'd be really useful, because we can turn that into 100% quite easily. So 80%, you've just got to think, what can you divide 80 by to get 10%? Okay, And actually we can divide 80 by 8. So we can divide that by 8 and that would give us 10%. So if we divide that by 8, we'd also have to divide this 512 by 8. Okay, whatever you do to one side, you do to the other here. So in order to divide that by 8, we're probably going to have to do some written methods. So I'm going to use a little bit of bus stop division. So 512 divided by 8, and we're going to work that out. So if we go ahead and divide that by 8, 8 doesn't go into 5, but it goes into 50, up to 48, doesn't it? So that's 6 times, it goes up to 48 with a remainder of 3 there, leaving us with 32, and then 8 goes into 32 4 times, there we go, so 64, so 10% was 64 of that original cost. Now we can turn that back into 100%, because once we've got 10%, to get that back to 100, you would times by 10, and that would give us 100%, so 100% there, timesing 64 by 10, would give us £640. There we go. So our final answer there is 640. Let's have a look at another question, but before we do so, just a little note is if you did have a calculator here, once you'd identified that 80% was a 512 in this step right here, if you have a calculator, and I'll write this to the side, you could just divide by 80, so 80% on a calculator, you could do divide by 80, which would give you 1%, and then you can just times by 100. So it's a slightly different process there. It's a lot easier if you have a calculator, because once you get 1% times by 100, or just add 2 noughts on, and that'll get you to 100%. Okay, but that only works if you have a calculator there. It's probably unlikely we're going to want to do 512 divided by 80 and then times it by 100 without a calculator. Okay, so a new printer costs £288 once 20% VAT has been added on. Work out the cost of the printer before the VAT. Okay, so this is quite common type of question here, because it's obviously used in business. Businesses can claim back the VAT. So if we have a look at what we've got here, when it's an increase in value, we do have to draw these bars slightly differently, because although we've still got these two sections here, we've got the 20% being added on, but that was added on to the original 100%. So we've got 100%, the original cost, but now 20% has been added on this extra VAT. So in this question here, we've got the VAT, and that's the cost of the VAT. This is the original cost, or the cost without the VAT. And then you've got the total in this case, which is the cost plus the VAT, and that is 120%. So slightly harder when we've got an increase here, so we've got 3 to look at. Now the original costs there we're not going to be looking at, because that's actually what we're working out here, work out the cost before VAT. So in this instance we've got either the 20% or the 120% down the bottom there once that 20% has been added on. So it says a new printer costs £288 once the VAT has been added on. So you've just got to ask yourself the question, is that the VAT that's been added on, or is that the price I'm actually going to have to pay, the 120% down here? And that actually, if you read the wording there, a new printer costs £288. It doesn't say that £288 VAT has been added on, it says that's what it costs. So that is the 120%. So I'm just going to write down that statement, 120% equals 288. Now I'm just going to take the exact same approach here. I'm going to divide this down and build it back up, but it's slightly harder here. I've got to think, what am I going to divide 120 by to get 10? And if you think, what do you times 10 by to get 120? That's 12. So in order to get down to 10, I'm going to have to divide by 12. So if we divide by 12, let's work that out, divide by 12. Not as nice when you're dividing by a double digit, but we can do that with just using a little bit of bus stop again, just being nice and careful when you do this. So we'll do this to the side. What have we got? 288 divided by 12, and let's figure that out. So 12 goes into 28 twice, up to 24, remainder 4, and then it goes into 48 4 times, so 24 there is our 10%. Okay, so 10% equals £24, and then nice and easy from there, just like the rest of these questions, we just times it by 10. So times that by 10, and that'll get us our 100%, so 100% equals, and that'll be £240, and there's our final answer there. So obviously just making sure you write that with your pound sign, that's £240 as a final answer. Okay, so in a box of cereal, 40% of the weight is nuts. The rest of the cereal is corn. Write the ratio of the weight of nuts to the weight of corn and give your answer in the form 1 to n. Now if we start by writing the ratio to start with, we've got nuts to corn, and that is 40%, and the other percent would be 60%. So that must mean we get our ratio as 40 to 60. Now this isn't too bad. To get this in the form 1 to n, then we just need to look at the number on the left and think, what do we divide that by to get it to 1? And the answer is always just to divide it by itself. So we're going to divide it by 40. And when we're simplifying a ratio, we're going to do the same to both sides. So we're going to divide the other side by 40 as well. So we already know that's going to make 40 become 1. And for the 60, you can just type that in on your calculator. So 60 divided by 40, and it comes out as 1.5. Or of course you could write that in a fractional form. You could write it as 3/2, but that comes out as 1 to 1.5, and that would be our final answer. And that's how you go about writing ratios in the form 1 to n. Okay, so again, there's nothing more complicated in this question. It's just there's a little bit of different wording going on. So it says Maria, Dylan and Kate share £3,000. The ratio of the amount that Maria gets to the amount that Dylan gets is in the ratio 5 to 4. And Kate gets 1.5 times the amount that Dylan gets. Work out the amount of money that Dylan gets. So we want to have a look. How are we actually going to create this ratio? Because at the moment we've got Maria, we've got Dylan, and we've got Kate. But it only tells us the ratio, and that's, so let's just highlight that. Dylan and Maria, or Maria and Dylan, 5 to 4. So we've got 5 to 4 for Maria and Dylan, but we don't know how much Kate gets in terms of parts of the ratio. But it does then say Kate gets 1.5 times the amount that Dylan gets. So Dylan gets 4 parts, so if we times that by 1.5, that actually gives us a value of 6. So Kate is getting 6 parts. Remembering multiplying by 1.5, if you don't have a calculator, just adds an extra half on. Half of 4 is 2, add it on gives us 6. So now that we've multiplied that by 1.5, the rest of the question's nice and easy. Because all we're going to do now is split that £3,000 in the question in the ratio 5 to 4 to 6. So if I get rid of this little bit of working out, this times 1.5, let's have a look. In total, that ratio adds up to 15 parts, and now we know that those 15 parts equal the £3,000. So we can find the value of 1 part again by dividing by 15, and 3,000 divided by 15 gives us a value of 200. There we go. So they all get 200. So we can go about timesing them all by 200. We're actually only concerned about Dylan in this particular question, and Dylan gets these 4 parts here. So we can just answer that straight away. Dylan's 4 parts, each one of them's 200 quid. So 4 times 200 gives us £800 for Dylan. There we go, and there is our final answer. And again, you could go about obviously finding out the amount that they all get. We could do Maria times 200, which is 1,000, and Kate's times 200, which is 1,200. And you could even add them all together then and show that there's £3,000 there. But that's how we'd approach a slightly different question here. We've got to think about creating the ratio slightly ourselves. Okay, so we've got something slightly different here. It says a shop sells small chocolate bars and large chocolate bars. The small chocolate bars are sold in packs of 4 and the large chocolate bars are sold in packs of 9. The packs of small bars are sold one day to the packs of large bars sold are in the ratio 5 to 2. Let's just highlight some of the information here. We've got small, packs of 4, large, packs of 9, and then we've got small to large in the ratio 5 to 2. And then it gives us this next bit of information. It says a total of 95 chocolate bars were sold. Work out the number of small chocolate bars that are sold. So at the moment, what we've got a ratio here about the amount of packs of bars sold, and we've got the information down the bottom about the amount of bars sold. So unfortunately, we can't just split that ratio 95 there in the ratio 5 to 2. We can't just do 95 divided by 7 because that ratio there is not about the amount of chocolate bars, it's about the amount of packs that were sold. So all we want to do is turn this ratio here into an amount of what's that one there? Into amount of actual chocolate bars. So if we actually go about doing that, 5 to 2, we've got 4 in each of the small chocolate bar packs. So if we times that one by 4, that tells us how many chocolate bars are in there. So that would be 20. And in the large one, we've got packs of 9, and we've got the ratio of 2 of those. So if we times that by 9, and that gives us 18 chocolate bars. There we go. So in terms of actual chocolate bars, that ratio there is 20 chocolate bars to 18 chocolate bars. So that's the ratio we're actually looking at. We've got small to large, and it's now 20 to 18. Again, if it told us down here the amount of packs that were sold, we wouldn't actually need to do that, but because the information there says the amount of chocolate bars that were sold, we just need to change that ratio into being an actual amount of chocolate bars there, which we've done. We've changed our amount of packs into chocolate bars just by timesing that one by 4 and timesing that one by 9 for the amount of chocolate bars that are in each pack. So if we have a look now, our total for this ratio adds up to 38. So we've got 38 parts equaling 95. Now that's not very nice, because immediately in my head I'm thinking, hold on, 95 does not divide by 38. If that's 38 parts equaling 95, that is not going to fit in. But let's go with it, let's see what happens. So we've got, and let's just write this to the side, we've got 38 parts equals 95 chocolate bars. So we'll divide that by 38, so we'll get 1 part. And let's just see what we get. We get 1 part equals, so 95 divided by 38 gives us a value of 2.5. And that's not very nice at all, because actually we're looking at that and thinking, hold on, we can't have 2.5 chocolate bars in each part. But let's not forget there's going to be 20 parts and there's going to be 18. So let's see what happens when we multiply these out. So if we do 20, I'm going to do this in a different colour again. Let's mix this up a little bit. There we go. So we've got 20 times by the 2.5 for the small ones. Let's just label that as small. And we'll label our large one as well. So 20 times 2.5 gives us 50. There we go, so it's gone back into a nice whole number. And also for the other one, we've got 18 times 2.5. There we go, and 18 times 2.5 gives us 45. There we go, and as you can see, they both add up to 95, don't they? And they're nice whole numbers now. Now the question obviously didn't ask us to work them both out. It said work out the number of small chocolate bars. So our number of small chocolate bars is right there, 50. So our final answer, there we are, is 50. Right, there we go. So it says here y is directly proportional to the cube root of x. So straight away, before we even read on, we can write y equals k lots of, and then the cube root of x. And then straight away we can start reading our next line. So we've got when y is 1 1/6, when x equals 8. So we can plug those numbers in. So first things first, I would rather not put 1 1/6 in, especially considering that I'm not using a calculator. I would much rather turn that into an improper fraction and then obviously use that. So I'm going to write that as an improper fraction, which is easy enough. So 1 times 6 is 6, add the 1, which is 7 over 6. So I'll put that in place of y. So 7 over 6 is equal to k lots of the cube root of x, so the cube root of 8. Now we know that the cube root of 8 is 2, so let's write that over here. The cube root of 8 equals 2, and actually we can just get rid of that then and put 2 in its place. So let's get rid of that and put 2. K2. Now obviously when we're looking at using algebra, we prefer to put those numbers, or we're going to always put those numbers in front of the letter. So rather than writing K2, let's write 2K. So let's get rid of that again and put 2K, and there we go. So 7 over 6 is equal to 2K. Okay, so as I said, the reason that we've written there 1 1/6 as an improper fraction is for this next step now. So what we're now able to do is apply normal fraction rules. So we've got to divide both sides by 2 to get our value of k. And because we've got 7 over 6 there, we can just apply those normal fraction rules. So we need to do 7 over 6 divided by 2, and to keep it as a fraction, I'm going to write 2 as 2 over 1. So there we go, and that's going to isolate k and mean we can find that value. And obviously just normal fraction rules here, so we'll flip over that 2 over 1 and make it 1 over 2. So we've got 7 over 6 times 1 over 2, which equals 7 times 1 on the top, which is 7, and 2 times 6, which is 12 on the bottom. So 7 over 12 is equal to k. There we go, so our non-calculator methods here. Obviously that'd be nice and easy if we had a calculator, because we'd just type in 7 over 6 divided by 2. But there we go. Moving on to our next step then. Now we've got our value of k. We just need to put that back into our formula. So our formula is y equals k lots of, and now we know that k is 7 over 12, we can put that in. So y is 7/12, and then the cube root of x. And there we go, there's the formula that we're going to use. Now it says here, find the value of y when x is 64. So this is actually a relatively nice one in the sense that we are not going to have to rearrange this, because when we put that x equals 64 into this formula, it's going to straight away give us our answer. Again, though we don't have a calculator, so we do need to do it without a calculator, but we're going to get our answer straight away. So we get y is equal to 7 over 12 multiplied by this cube root of x. So let's do this working out here. The cube root of 64, which hopefully you know is 4. 4 times 4 times 4. So we've got 7 over 12 times 4. And there we go. Again, we can just treat that like normal fractions. 4 could be written as 4 over 1, and if we times the top there, 7 times 4 is 28, and 1 times 12 is 12. So we get a final answer there of 28 over 12. Now again, it is a fraction there. We should be applying our best practice and simplifying that down. The top and bottom both divide by 4, so that'd be 7 on the top and it'd be 3 on the bottom. So there we go, obviously always applying that best practice of simplifying your fractions. So our answer there is 7 over 3, although we could be okay there writing out the answer as 28 over 12 as it hasn't asked for our final answer to be simplified. Again, we could even convert it into a mixed number. We could write it as 2 1/3, but there we go, there is our final answer, 7 over 3. Okay, so for this question it says a train travelled from Manchester to London. Train A left Manchester at 8:35 and arrived at 11:05. So train A, 8:35 and arrived at 11:05. The train travelled at an average speed of 110 miles per hour. It says train B also left Manchester at 8:35 but was diverted by an extra 37 miles. Just to highlight this one, train B also left at 8:35, diverted by an extra 37 miles, and it got to London at 11:35. Work out the difference between the average speed of train A and train B. Okay, so for this one here, we actually have two separate journeys. We have train A, which is going to leave Manchester to London, and there we go. If we just label that up, and we'll put the times in as well so we can work this out. So Manchester to London, it leaves at 8:35, and it gets there at 11:05. Again, you don't necessarily have to draw these diagrams, but just to help us to visualise it. We have train B, and that is going to leave Manchester to London, the same journey. It leaves as well at 8:35, but this train arrives at 11:35, so half an hour later than train A. And there we go. So for each one of these journeys, we're going to have a look at a speed, a distance, and a time. And of course, this question wants to work out the difference between the average speeds, so we may or may not already have a speed for one of them or both of them. Of course, if we already had the speed for both of them, we could work it out straight away, so we're definitely not going to have both of them. So for this first one, train A, it leaves at 8:35 and arrives at 11:05. So that is a time of 2.5 hours. So if we keep that in hours, that would be 2.5 hours. For the next part of that, it also says it goes at an average speed of 110. So it goes at an average speed of 110, that's in miles per hour. So straight away we're going to be able to work out a distance. Let's have a look at the second part of the journey though. This one leaves at, or the second train, this one leaves at 8:35 and gets there at 11:35. So that is a time of 3 hours. So that's going to be 3 hours, again just half an hour longer, but it is diverted by an extra 37 miles. So we'll be able to add 37 onto the distance once we know the distance of the journey. So we just need to remember that, so I'm going to underline that because we're going to start with train A. Now again, just remembering your formula for this, so every question always write it down. We're going to look at speed, distance and time. And there we go. So for the first one, we're working out a distance, so that is going to be speed times time. So we need to work out 110 times 2.5. Now again, in order to work that out, you can just do your working out to the side. So if we take the decimal out, that would be 110. We'd multiply it by 25. So 5 times 0, 5 times 1, 5 times 1. Placeholder, 2 times 0, 2 times 1, 2 times 1, and add it all together. So that'd be 0, 5, 7, 2. Hop your decimal back in, so we're hopping it back in once, so that comes out as 275. So there we go, that is a distance of 275 miles. Again, I'm going to write miles this time because I've accidentally said meters on the question before, so we don't want to get confused between miles and meters for this. So for this one here, we'll get rid of that working out. Obviously you want to leave all your working out, but just to show you there, you can always do your working out to the side. Of course, multiplying by 2.5, you could just double it and add on a half as well, if you know some little tricks with your multiplication, but if not, just do your multiplication to the side. So that 275 miles is going to be the same as the distance over here. But of course we have the extra 37. So we need to do 275 plus the additional 37 miles that train B was diverted, and that gives us 2, 12, 7, 10, that's 11, carry the 1, 312. So this one over here has had to go 312 miles. And there we go. Now we can go about working out the speed for this journey. So for this one here, to get speed, we're going to do distance divided by time, so we need to do 312 divided by 3. And again, we can just do that to the side using some working out. So 312 divided by 3. 3 goes into 3 once, doesn't go into 1. Carry the 1, it goes into 12 4 times. So the speed over here is 104, and again that's in miles per hour. So there we go, we have our two speeds. We had 110 from the question, 104 from what we've just worked out, and it wants us to work out the difference in the speeds. So in order to get the difference, our last little bit of working out, and you can do this in your head, but obviously we'll show our working out for this, it would be 110, take away 104, and when we do that, you just get the answer 6, and that is 6 miles per hour. And there we go, that's our final answer, and that is the difference between their speeds. Okay, so this question says Harry travels from A to B at an average speed of 50, and then he travels from B to C at an average speed of 70. Harry takes a total of 5 hours to travel from A to C, and the distance from B to C is 210. Calculate Harry's average speed. Right, so let's have a look at this one then. So we've got A to B, and we've got B to C, and then we've got the total overall journey there. There we are. And thinking about what we've got a speed, distance and a time, and we'll see what happens in this question. So in this question here, let's have a look. We've got an average speed of 50 for the first one, an average speed of 70 for the next one, and then we've got a total time of 5 hours from A to C. So this time we've been given our total. Look, we've got 5 hours as our total, and we've got the distance from B to C, which is 210. There we go, so 210. Right, so let's have a look at how we can now go about working this one out then. So ultimately we are looking for the average speed for the total journey. So we're looking for this one here, but we're missing quite a lot of pieces. Now what we can do is we can start to work backwards. So if we have a look at this first section here, this second journey from B to C, from Brockley to Cantham, if we can go about working that out, we can get this time down below, and we can definitely do that. Speed is distance over time. So time down the bottom for this first little box that we can work out here is distance divided by speed. So 210 divided by the speed, which is 70, and that gives us 3 hours for that part of the journey. Now we can work backwards because we know that these two journeys have to add together to make 5. So the other part of the journey, if we do 5 take away 3, tells us that this first part of the journey must have been 2 hours. And now we've got that, we can work out the distance of that journey. Distance is speed times time. So this one here, speed is 50 and the time is 2, so that must have been 100 miles. There we go, and now we can get our total distance for that journey there. So we've got 100 plus 210, and that equals 310. And now we can just finish it off like a normal question. So it's not particularly any more difficult than the previous questions. It's just actually working backwards to go back to that first part of the journey so that we could get the overall distance for this total journey here. So now we can do our normal sum. We've got distance divided by time, so we've got 310 the total distance divided by the 5 hours, and 310 divided by 5 is 62 miles per hour. There we go. And also thinking about the logic here, that is in between 50 and 70, so our answer makes sense. And you should always be thinking about that. Does my answer make sense? Is it somewhere in the middle of the two? Now this little bit of language here, xn plus 1, just means in very simple terms to find the next solution, okay? And that's what we use iteration for, to find estimates to a solution to an equation. So to find the next solution. Okay, so I'm going to be using that language throughout the video, but that just means to find the next solution. So if you can change your mind on what you think that actually, represents there with the little n plus 1, just think of it as to find the next solution. Now the next thing we have to do is think about obviously what this little n here means, and that just means the current solution. Okay, the current number that we're going to be using, or the current solution. Okay, there we go. So to find the next solution, you do 5 divided by the current solution squared, add 3. I'm going to type this all into a calculator, and it gives us a starting number, and it says here x0, and that just means our starting number. There we go, so starting number, and it says the starting number that we're going to use equals 1. So all we actually have to do is sub 1 into this iterative formula. So what we're going to do is write down our first solution. It says find the values of x1, x2, x3, which are just the first 3 estimated solutions. So to find the first estimated solution, which we'll call x1, we do 5 divided by the current number, or the current solution, which is our starting number at this point, which is 1. So 1 squared, add 3. And when we work that out, we get 5 over 4. Okay, 1 squared add 3, just typing that into your calculator. So type that all in, use your fraction button. Again, obviously this is much easier if you are using a Casio calculator. Your fraction button here is 3 buttons down from the top left, and it looks like this with the top one shaded in. Okay, so obviously it's much easier. I have linked in the description below the calculator that I'm using, and also another calculator that I like as well, but the one I'm using is the first in the description. The one I use on a daily basis is the second in there, but I would recommend you getting a Casio calculator, and again I've linked them below so you can have a look, and you know, if you know anyone that has one, obviously do have a go at using theirs. But there is our first solution. Now with that typed in on your calculator, it's on my screen right now. I've got 5 over 1 squared plus 3. I've pressed equals and I've got 5/4 on my calculator screen. Now we're going to find x2. Now our current solution is 5 over 4. So I'm not going to use 1 anymore because we just keep getting the same answer, but instead I'm going to put 5 over 4 in place of this 1 here that we put in to start with. So 5 over 4, I'm going to put that in a bracket, squared plus 1, sorry, plus 3. Okay, and if we type that in, and I am going to do a little trick here, rather than typing in 5/4 in this little place here, I'm actually just going to use my answer button. So I'm just going to delete the 1, and I'm just going to press the answer button. I'm going to be doing that throughout the video. Okay, and all that's going to do is that's going to put this last answer on my calculator screen, this 5/4 in for me. So press equals, it does it all for you, and again it gives you a horrible decimal, but it does actually come out as a fraction. It comes out as 80 over 73. Okay, so that is x2 there, finding our third solution. Let's just highlight that so we can see where it is. There we go. And now we're going to find x3, our final solution, and that's the number that we're going to use there in x3, our working out of x3. So to find that, we are going to do 5 over, again, the current number squared, so I'm just going to use the answer button again. So on my calculator it says answer squared plus 5 plus 3 again, sorry. There we go. And easy enough at this point, I can just press equals again and it will reuse my current answer that's on the screen at the moment. So just make sure you don't clear anything off your screen, just keep it there, press equals, and there we go. And it gives me a decimal answer for this one, no fraction this time. It gives me 1.19, lots of decimals, so it doesn't say to round it, so I'll write it all down. 0.1996669. There we go, and that was our final answer there, x3. So these are estimates to the solutions of an equation. That's what we use iteration for, to find estimates to the solutions. And obviously these are our 3, so we've got x1, x2, x3. Write them down nice and clearly, don't round them. It's fine to write them as fractions, but definitely don't round them. Okay, so looking at this question, we've got 2 parts. So the first part says, show that the equation 2x cubed minus x squared minus 3 equals 0 has a solution between 1 and 2, x equals 1, x equals 2. What that means is that there is a number between 1 and 2 that would sub into this equation to give us the answer 0. So if we look at how we can actually show that it must be between 1 and 0, we could just go about subbing these numbers in. So if we sub x equals 1 in to start with, let's have a look at what we get. So if we sub x equals 1 in, we get 2 lots of 1 cubed, or 2 times 1 cubed, take away 1 squared, x squared, and then take away 3. And if you sub that all in, you get the answer -2, which is obviously less than 0. Now if we sub in the next one, if we sub in x equals 2, and see what we get, let's have a look. And you just type this straight into the calculator. You get 2 times 2 cubed this time. Take away x squared, so take away 2 squared. Take away 3. Let's have a look, and that's going to give us, let's type that in, 2 times 2 cubed. Take away 2 squared. Take away 3. And it gives us the answer 9. There we go. So we've got 2 answers there. When we put 1 in, we get -2, and that's obviously less than 0. So that's too low. And when we sub in x equals 2, we get a number which is bigger than 0, we get 9, and that is too high. There we go. So 1 is too low, 1 is too high, and therefore it must be in between. There we go, it must be in between
There we go. So therefore it must be in between. If we have a look at the second part of this, it says starting with x naught equals 1, use the iteration formula, and it gives us this formula here twice to find an estimate for the solution to the equation that was given to us above. Now you might have another part in here as well. You might actually be asked to show how that equation can be rearranged to this iteration formula. I'm not going to go over that in this video. It's more about rearrangement there, but just thinking about how we can actually do that, you just have to look at these equations, and the original equation up here has an x cubed in, and the one down here doesn't have a cubed or a squared in. So we need to have a look at how we could actually go about that. Now first things first, that's a negative 3 on the left of that one, and it's a positive 3 on the right of this one. Now you don't actually have to do that to answer this particular question, but if we did have to rearrange it, first things first, we would have to add the 3 over. So let's have a look. We get 2x cubed minus x squared equals 3. Now if you have a look, there's no x squared here in our iteration formula, there's no x cubed, so I'm going to have to factorise what's on the left there, and you can factorise it by x squared, and you get x squared equals 2x minus 1, sorry, I've actually just messed that up there, that's not factorising at all, is it? Factorising it, putting it into a bracket, and we get 2x minus 1 equals 3. And then you could actually rearrange it so we can divide both sides by 2x minus 1, and you get x squared equals 3 over 2x minus 1, and then you can square root both sides to get to our iteration formula up there. So there you go, you could square root that for x and square root this, and that's what gives us our iteration formula. Now I'm just talking about that because that's how these iteration formulas are actually formed. They make one of the x's the subject. So in this case we've got x as the subject, we've got x equals the square root of 3 over 2x minus 1, and that's how this iteration formula over there is actually formed. And sometimes you might actually have to show that, but we're just going to focus on actually using it. But I thought it was worth showing you there how these are actually created and how it relates to the equation up there. So if we have a look at just following our normal process here, it says our starting number's 1, and it says to use it twice, or in other words it wants us to find x1 and x2. So in order to find x1, all we have to do is sub that number in, so sub 1 in, and we get the square root of 3 over 2 lots of x, or 2 times 1, take away 1. Okay, and type that in there, 3 lots of, let's press the square root button first, so 3 on the top and on the bottom, 2 times 1, and then take away 1. Press equals, and you get the square root of 3, which you can write down as the big long decimal. It's 1.73205, so on and so on, but it's the square root of 3 as our first solution. And if we put our next one in, so this time we're going to be putting the square root of 3 in, so let's actually just write that in. So we get the square root of 3 on the top, 2 times the square root of 3 on the bottom, and you can just put answer in, put 2 times root 3 minus 1. I'm just going to go back into my calculator, I'm going to delete the 1, I'm going to press the answer button rather than typing in the square root of 3, press equals, and again we get a decimal this time, we get 1.103395, and then 785, and again just writing down all the decimals. There we go, so we found x2, we've used the formula twice to get an estimate to our solution there. Okay, so lots going on in that question. You've got showing that an equation has a solution between two numbers. Nice and easy though, just sub them both in, show that it's in between the two answers at the end, so -2 and 9, it was between them. Then obviously using the iteration formula there, just like we did before, and just making sure you type it all in and write all your working out down. Okay, but obviously didn't ask you to rearrange it in this question, but you could actually be able to rearrange it. You've just got to take your time and have a think about how you could potentially rearrange it, and particularly in this question here, we've got to factorise at this stage here. That made it quite difficult in this particular question. Okay, so this one looks a little bit more complicated. We've got ATB as a tangent to the circle. Calculate the size of angle OTQ, and you must give your reasons. Now OTQ is this angle just here, so it's this little angle in between. Now we've got these lines on this triangle here telling us that it's an isosceles, that they must be the same length, and we know we've got a tangent, so we've got a 90-degree angle just here. And have we got anything else? Nothing else that stands out to me at the moment, so let's just have a look at what we can find. So in between the 58 and the radius there, we can obviously find that out. So this angle here, so we can do 90, take away 58, as obviously tangent meets a radius at 90. So 90 minus 58, and what does that leave us with? 32 degrees. There we go. So that angle there is 32, and we can draw that in.
There we go. Now there's nothing really that massively stands out that you can actually go for on this next movement now. Now obviously there are a couple of ways of doing this. I've just spotted two little things. We could draw another line in here and perhaps make a little isosceles triangle, but I'm just thinking, are there any other circle theorems that we can look for? Now we haven't got a diameter, we haven't got any angles in the same segment, we've not got our little angles at the centre or angles at the circumference circle theorem, but we have got like a cyclic triangle here for meeting a tangent, so we can actually apply our alternate segment theorem again. So actually if I go through this angle, this 58, and I go up the length of the triangle, it makes this angle here, so that there is going to be equal to the 58, so this angle here is going to be 58. Again, there's our alternate segment theorem. Now looking at that, obviously we've got an isosceles triangle, and we know base angles in an isosceles are equal. So if we work out the size of these two base angles here, we can do 180, take away 58, and that would leave us with 122 degrees. There we go, 122. Now that is needing to be split in half, obviously because it's two base angles. So if we divide that by 2, that would give us 61 degrees. So both the base angles in this isosceles are 61. There we go, I can just about label that one there as 61. There we go. And now looking at this value of x, look, we know that part of that angle is 32 and the full angle there is 61. So that little value of x must be what makes 32 up to 61. So we can finish this off by doing 61, taking away 32. And what does that leave us with? That leaves us with 29 degrees. There we go. So 29 degrees would be our final answer for that one. There we go. A couple of different ways that we could have approached that. Actually, I think you could have also done a little bit of an isosceles triangle here, had two base angles of 32, then found the angle at the centre here, and halved that for the angle at the circumference and worked your way through it that way. But there's always a couple of ways to solve these questions. I think that way obviously just involved a little bit less drawing and having to sort of think outside the box. But there we go, there's a way of doing that question as well. Let's have a look at another one. Now it says here that angle or A, B and C are points on the circle of radius 5 centimetres, centre 0. So we can see that on the diagram. We've got the radius drawn in there and it's been labelled with that 5 centimetres. And we are going to be looking for the length of an arc in this question. So let's just have a look and read through the rest of it. It says DA and DC are tangents. So we've got these two lengths here that are tangents. So we've got these tangent questions being sort of in a lot of these sort of exam questions. So it's definitely a very important one for us to know. And we have DO is 9 centimetres. Now that length there is not on the diagram. So we need to label that on straight away. As soon as we read that information and we see it's not on the diagram, we'll label that on. So that's length here, 9 centimetres. It says work out the length of the arc ABC. And ABC is the big one here around the outside. And in order to work out the length of that arc, we're going to need to know the angle of that major sector there. So we need to get that angle around the outside. Once we've done that, we can use our circumference formula or arc length formula in order to get that arc length. But let's have a look. So what can we work out? Now we already mentioned that there's some tangents. So we know that this is a right angle and this is a right angle as well. And what we need in order to get that angle out on the outside, we need these angles just here. Okay, so there's two of them. Now that quadrilateral there is split perfectly in half, okay, to form two right angled triangles. And those two right angled triangles are congruent, so they are exactly the same there. The tangents meet at equal length. They're both 5 centimetres as the radius, and they both share that 9 centimetre line. So these are two congruent triangles. So if we find the angle in one of those, we can double it up and then find the angle around the outside. So that's how we're going to approach this question. Now, in order to find that angle there within a right angled triangle, we are going to be using a different topic. So we're going to be using SOHCAHTOA. So in order to find that angle there, if we think about this, we have got, and if I draw this triangle, maybe let's draw it down here. We've got a right angled triangle. We're trying to find this angle here. We have that the hypotenuse is 9 centimetres and the adjacent side to the angle there is 5 centimetres. And again, just doing a bit of SOHCAHTOA, so label it up, you've got your hypotenuse and you've got your adjacent. So we're going to be using cos. So cos, or if you use a formula triangle, CAH, and we're going to be working out the angle. So we need to do cos minus 1, A over H, which is 5 over 9.
So again, let's type that into our calculator, cos minus 1, and then 5 over 9, pressing equals, and we get our angle there, which is 56.251 0.114. So that is that angle just here in the centre. Now obviously we've got two of those, so we need to double that to get the full angle. So let's just get rid of this. So this full angle here is going to be 2 lots of the 56.25. So 2 times, that's not a 5, let's do that again. 2 times 56.2510114. So times by 2 on the calculator, and we get 112.502 and 0.228. Now notice that I am leaving all of the numbers there when I write it down. It's asked me in the question to give my final answer 3 significant figures, so I don't want to get any rounding errors along the way. So unless it's going off the screen on the calculator, I will always write it up to at least 7 decimal places. Now this one doesn't actually stop at 7 decimal places, but we'll leave it there just to make sure it's as accurate as possible. Now we can go about working this angle here. Again, angles around a point add up to 360. So if we do 360 and we take away this 112.502 number, I'm not going to write them all down there because I'm typing this in on the calculator, 360, take away answer, and it gives us a final angle there of 247.4979772. There we go, degrees. So that's our angle there in the major sector. Now we need to find the length of the arc. So we need to know our formula for working out arc length. So another topic that's involved in here. So we have pi times by the diameter, or times by 2r, whichever formula you use, times by the angle, which I'm going to call theta, over 360. So if we plug all these numbers in, we have pi times the diameter, which is 2 of those 5s, so times 10, times by this angle over 360, so 247.49, and the rest of those numbers all over 360. So again, I'm going to use the answer button on my calculator. So leaving that answer there, pi times 10 times, pressing my fraction button, answer over 360, and it gives us an answer here, which comes out as 21.59827.297. And again, then referring back to the question, it wants it to 3 significant figures. So that's going to be 21 point. The third significant figure is the 5. It's a 9 afterwards, so that's going to go up to 21.6. And the units are centimetres. So we get 21.6 centimetres for this question. So there we go, you can obviously see how that one's a lot trickier. It doesn't actually involve that many circle theorems. It obviously involved the tangent to the radius being 90 degrees, and it involved knowing that 2 tangents meet at equal length. But other than that, it didn't involve too much in terms of the circle theorems, but it was using circle theorems to solve a much harder problem.
Okay, so looking at the area of a trapezium, and as with the other two, how does this relate to a rectangle? And you might have already spotted it's in a similar way to how our parallelogram did, and that is if we cut off this triangle at the end and we were to rotate it and flip it around to the other side and just slot it in just at the end there, we would end up having a rectangle. Obviously that's deleting this triangle off the end. So this is also related to a rectangle, but we need to think about how it relates, because by doing that I have taken away part of this 12 centimetres and I've added that part of that 12 centimetres onto my 8 centimetres. So what we're actually doing is we are reducing the length of the base and increasing the length of the top in this particular example. So we need to figure out what the length of that rectangle would be, and the way to do that is we look at both of those lengths and we find their average. So to find the average of 2 numbers, you add them together and divide it by 2. And that's what starts to form our formula. And when it comes to the formula of a trapezium, what we actually do is we take the top and the bottom, let's call that A and B, we add them together and divide it by 2. So A plus B divided by 2. And then we multiply that by the height, just like we do with a rectangle. So you multiply that by the height. Now again, there are 2 ways of writing this formula out. there is another way that we can use the fraction a half. So we could say it's a half of a plus b, and then we don't have to put that times sign. We could just get rid of the times sign and instead just put the letter h. So it's a half of a plus b multiplied by the height. So if we take that into account for this particular question, we're going to add together a plus b, and that is 8 plus 12. So 8 plus 12 is equal to 20. And take note of the fact here that we have to pick those two parallel lines as shown in the trapezium. If we were to add together the diagonal lines, well, they wouldn't be part of that rectangle that we made. So it has to be the two parallel lines, and that's what A and B are. So it's worth writing that down as part of your notes, that these are the parallel lines. There we go, when we are working out the area of a trapezium. So we've added them together, we've got the answer 20. Now thinking back to our formula, we do need to make sure we divide that by 2, and that's what doing this half here also does, depending on which formula you prefer to look at. So 20 divided by 2 gives us an average length of the rectangle of 10. So that 10 there is what we found when we cut off this part of the triangle and added it onto this part here. What we've actually found out here is what we would have done is to subtracted 2 from this length and added 2 onto the length just there. That would make the length go from 8 to 10 on the top, and the length on the bottom go from 12 to 10. And that's what we have just found. So if we get rid of that, and then we need to just work it out. So we found that a plus b divided by 2 is 10, or the average length is 10, and then we just have to multiply it by the height, and you can see in this trapezium the height is 5. So to finish this off, we would do 10 times 5, and that gives us a final answer of 50 centimeters squared. And there we go, that is how we work out the area of a trapezium, and our answer is 50 centimeters squared. So very quickly running through that before you have a go, you do a plus b, which are the two parallel sides, you add them together, divide it by 2 to find the average length, and then multiply it by the height. Exactly the same as we would do for a rectangle.
Okay, so this question says triangles ABC and ADE are mathematically similar. Let's have a look at that. ABC is this triangle here sitting on the top. And then it also says that's similar to ADE, the larger triangle that we can see around the outside. So what's actually happening here is the triangle is within or inside the other one. Now when it comes to a question like this, and you don't have to do this, but I would say if you're struggling to see the two triangles separately, just redraw them both, and they don't have to be perfect. Look, all we're going to do is draw one slightly bigger and one slightly smaller, and they're by no means perfect. So this one here is A, B and C, the smaller one, and the larger one is A, and then we've got D and we've got E. And we just need to make sure that I put those side lengths on it as well, just to make sure it's nicely labelled. So we've got the 12.5 down the bottom of the smaller one, 12.5. And then we've got 15 on the side of that. I just need to be careful for the last bit, because for the last bit we've got the full length here of A to E. So it's the combination of the 15 and the 6 there, so that makes 21 on the length of that larger triangle. So 21, the 15 and the 6. Now you might be able to see it slightly clearer, because now we've just got two shapes just like the previous questions. So in order to get the scale factor this time, we just need to obviously compare this 21 and this 15, just obviously making sure that we are very careful when we're doing this, we do get that combined length. So 21 divided by 15, and that does simplify, but if we've got a calculator, 21 over 15 gives us 1.4 as our scale factor. And that's obviously our key number in this question. And it says to calculate the length of D to E, which is quite nice and easy now. We just need to get this length down the bottom. So we're going from the smaller to the bigger one. So we're just going to times by 1.4, which is our scale factor. And 12.5 times 1.4 gives us the answer 17.5 centimetres. There we go, so our final answer there is 17.5 centimetres.
Okay, so this question says work out the length of BC. Let's just identify that there. So the length BC is this length across here. And it says give your answer correct to 3 significant figures. Now straight away it doesn't actually stand out that you definitely need to use Pythagoras for this, but we are working out lengths, and Pythagoras is one of the skills we have to work out lengths in different shapes. Obviously only when it comes to right angled triangles, but different shapes, if we can find a right angled triangle somewhere, we can apply Pythagoras to help us work it out. And in this type of question, look, if I chop from the D down to the base,
that creates a right angle triangle here on the right, and we have a rectangle on the left. Now because it's a rectangle on the left, we can say that the 2.1 there is the same as the 2.1 down here, and that's in meters, and the 1.9 there is the same as the 1.9 over here. Now that means that we've got enough lengths in this right angle triangle. Now we've got the 3.2 and the 1.9 to work out the lengths down the bottom here, which I'll put a little X next to. And then once we've got that, we can combine it with the 2.1. So looking at that right angle triangle we've got the hypotenuse look opposite our right angle. So we're going to do square square and then minus and then root. So 3.2 squared, take away 1.9 squared. We'll work that out and then root the answer. So on the calculator, 3.2 squared, take away 1.9 squared, and that equals 6.63. There we go, 6.63. So square rooting that, so 6.63, the square root of that, and that equals, let's have a look, 2.5748. 2.5748 and a few more decimals. Now again, it says it wants our answer correct to 3 significant figures. Obviously just make sure you read that. So if we round this to 3 significant figures, we get 2.57. There we go. And this is in meters this time, so 2.57 meters, and I can label that down here, 2.57 meters. Now I can work out the full length of BC there, because we've got the 2.1 and the 2.57, and if we add those together, 2.1 plus 2.57 comes out as 4.67. So let's just write the working out for that down up here. 2.1 add 2.57. I should probably tidy that up with a 0, and that comes out as 7, 6 and 4. So 4.67 meters, and there is our final answer for that question. Now obviously when you're looking at 3D trigonometry, it is going to be very important that you are pretty comfortable using SOHCAHTOA, and then pretty comfortable as well using the sine or cosine rule if they do crop up, which they may well do in some of these questions. So do make sure that you're pretty clued up on those topics first. Again, they're going to be linked in the description below in the trigonometry series, so do check those out. But we're going to get started and run through some of these questions. So this first one here, it asks us to find, and let's just have a look at the information in the question. And one thing I'm going to do on these is that I've not really looked at these questions in depth. I've seen them in the past, but I'm just sort of going to run through them as I would sort of approach them if I was to be sort of sitting these in an exam. So let's have a look and read the question. So we've got a cuboid, and it's quite nice, this one. It's drawn some lines in for us. It's going to help us along the way. Again, we'll discuss that as we go, but it says here we've got angle EDH is 64. So we need to label that on. So let's find EDH. So E to D to H is this one down here on the base. So on the base there, that is 64. Can just about fit that in. Then we've got the next one. ACD is 28, so angle A to C to D, and that's over there on the back face. There you go, just back there, and that's 28. Right, there we go. And then we've also got the E to H is 15, which is given to us on the diagram, but that is also going to be the same as the one back here, and also the ones on the top there, but I'm going to minimise the amount of labelling that I do. So I'll put 15 back there because I'm assuming that I'm probably going to need to know that. And it says work out the size of angle. I'm going to do this in a different colour. Angle AHD is what we're looking for. So A to H to D is on this inner triangle there, and that's what we're trying to work out. So I'm just going to put a little X in there just so I remember what I'm actually looking for. So looking at that triangle on the inside, we've got AHD, that triangle. If I draw that over here, and this is the little trick with 3D trigonometry, always to redraw these triangles to the side and sort of take it away from the 3D picture. But I'll label all the corners so you know which one I'm looking at, A, H and D. Okay, and at the moment we are looking for this angle here, and we don't have any of the other side lengths involved with that triangle. Now there's a couple that we can probably find. I'm just thinking on the back triangle, so on this back one here, there we go, I'll label that up. We've got one of the angles and a side length. So if we go about using SOHCAHTOA, we can work out the length of A to D, which is going to be this length here. And once we've got that, that'll be one of our pieces towards that triangle there, because obviously we can find that angle as long as we've got two sides using SOHCAHTOA. So I'm going to start with that one over there. That's going to be the first one that I'm going to find, and that's going to give me one of the two pieces that I'm going to look for. And we'll have a look at what other piece maybe we can find afterwards. But let's look at that back triangle to start with. So again, I'm going to draw this to the side. We've got a right angle triangle, let's C there, D here, and A at the top there. There we go, and we've got this angle here being 28,
and we've got the bottom there, which is 15. So I'm going to work out this one here, the side that's opposite the angle there. So using SOHCAHTOA, we've got the opposite. Remember to label it up. We've got the opposite, and this is the adjacent. So there we go. We're going to use tan for opposite and adjacent, and we're working out the opposite. So that is going to be a multiplication there. We're going to do 15 multiplied by tan 28, and that's going to tell us the length there. And again, obviously, those of you that like to use formula triangles, there you go. TOA, we're looking for the opposite, so it's a multiplication. So 15 tan 28, and all these are going to be on the calculator, so I'm going to be doing this on the calculator. So we've got 15 tan 28, and that gives me an answer here of 7.975. Now the final answer, look down the bottom, wants it all to 1 decimal place. So I'm going to leave all my answers to about 3 decimal places, so I will be rounding them to 3 decimal places as I go, rather than writing all the working out down. But 7.976 if I round it to 3 decimal places, there we go. It's 5.6 there, so that rounds up to 976. Right, so that's that length. Let's label that on the diagram. 7.976 just there. And we can also label that on our final triangle up here, which is 7.976. There we go. So we need one more piece. Now, let's swap to a different colour to look at this next one. Now, we've been given that angle 64 on the bottom. So if we have a look, and this is the triangle, I'm going to swap to a different highlighter here. I'm now looking at this triangle that's on the base, which is a right angled triangle, as we've got that angle there in the corner, right in the bottom left corner of the cuboid. So I'm going to redraw that triangle separately, and I should be able to get this length here, and that's going to be this length here on our final triangle. And once I've got that, we'll be able to finish this question off. But let's draw this triangle on the base. So on the base there, if I draw the base out, again, I could draw it as a rectangle. You could draw this line in if you want, but I'm just going to remove that. I'm just going to look at the actual right angle triangle. So we've got 64 up here. There we go. We've got 15 centimeters again down here, and we're looking for this length here. So that is D, E, and H. It meets that down there. Right, there we go. So that's enough information there for us to actually work out the length of X. So if I label this up using SOHCAHTOA again, so we've got the opposite. And we're looking this time for the hypotenuse, so we're going to use sine. And again, if you want to write down your formula triangle, SOH, we're looking for H. So we're going to do a divide. So we've got 15 divided by sine 64. There you go, 15 divided by sine 64. And let's just work that out on the calculator. So 15 over sine 64. And that gives us 16.689. Okay, so 16.689. There we go, let's label that on the diagram. 16.689. There we go. And we can then label that obviously on our triangle over there on the left. So now we've got 16.689 for the bottom there. And now we can actually finish the question off. Now we've got that triangle on the left there. We've got all the side lengths we need, or 2 of them at least, so we can find the length, the size of the angle. So opposite that angle, there we go, we've got that, the opposite, and we've got the adjacent down here. So again, we're going to use tan just like we did in the first triangle, but we're going to be finding an angle this time. So remember, just keep writing down all your formula triangles if you use them. We're looking for tan, so the t part, the angle, so we're going to do tan minus 1, so shift tan, just to make sure we tell the calculator we're looking for an angle. And when it's opposite over adjacent, so it's 7.976 all over 16.689, and then close your bracket. Right, let's type that in on the calculator. So shift tan, fraction, 7.976, and then on the bottom 16.689. Come out of the fraction and close the bracket there. Press equals. There we go, and we get an answer. We get 25.544. A few more decimals, but I'll leave it to 3 decimal places for the purpose of the working. And then it wants it to 1 decimal place, so we chop it after the 5. There we go, and we get 25.5 degrees. There we go, and there's our final answer for this first question. Let's just highlight that up. There we go, and there's our final answer. Right, so there's the first one. I do think that was a relatively nice one because it gave you those little diagonals drawn in, and a lot of the time you're going to have to draw them in yourself or visualise them yourself. But hopefully you see the little tips here that I'm sort of doing. I'm drawing these right angle triangles separate to the 3D shape just to help me sort of visualise it a little bit better rather than drawing all over that shape and making it a complete mess. Okay, so a slightly different question here. We've got some negatives in our vectors. We've got a negative on the top of A and a negative on the bottom of B. So that indicates a left movement of 2 there for vector A and a down movement of 1 for vector b. And it wants us here to write down 2a minus b as a vector. So we're going to do the vector 2a, so let's do that one to start with. We've got 2 lots of, and then we have minus 2 and 5. And we're going to take away from that vector b, which is 3 and minus 1. Okay, let's sort out this 2 lots of vector a to start with. So doubling both of those, we have minus 4 over 10. Okay, so just doubling those, and we're going to take away this 3 over minus 1. Now we're going to deal with the top numbers to start with. So let's just think about this numerically. We've got minus 4, and we're going to take away this time, we're going to take away 3. So minus 4, take away 3, leaves us with minus 7. And on the bottom there we just need to be careful because we're going to be doing 10 and we're going to take away that negative 1 on the bottom. So taking away a negative, that's obviously going to add 1. So actually we're going to do 10 add 1 here, and that's going to be 11. And there we go, there is our final vector, minus 7 over 11, written as a column vector. Okay, so for these next few questions we've got some visual vectors that we can actually see drawn on the grid. And it says in the question here the vector a and b are shown on the grid. And we've got vector a that we can see there going sort of upwards to the right, and vector b that we've got going downwards to the right as well. And it says for part a here, on the grid draw and label the vector minus 2a. Now obviously 2a will just be double the distance of a. The fact that it's put a minus in there means it's going in the opposite direction. So instead of our arrow pointing upwards, it's going to be kind of coming downwards to the left. So in terms of looking at this, we just need to establish what the pattern is of a, just to make sure that we draw this in correctly. And you can kind of see if we start from a certain point, we need to go across 1 and we go up 2. There we go, let's draw that again. So we go across 1 and we go up 2. Right, so in terms of actually getting the pattern here, we just need to pick somewhere, hopefully not somewhere where it's going to overlap with a. So let's start down here. There we go. And we're going to go across 1 up 2, which gets us to there, across 1 up 2 again, and that will get us to there. Okay, so let's rub that out. So in terms of actually drawing the line in, that would be the vector 2a, double the distance of a and following that same pattern across 1 up 2. The fact that we're doing minus 2a just means we need to point the arrow in the opposite direction. So there we go, we can label that, that would be the vector minus 2a. And there we go, there's part a done for that one. Now for the other one, we've got to work out the vector a plus 2b as a column vector. And the process of looking at the pattern is really going to help us for this. So we looked at the vector a to start with. Now that vector a, and we can write this down over here, the vector a, it went across 1 and up 2. So that would be 1 in the positive right direction, and then 2 obviously being a positive in the up, moving upwards. So there's our vector a, 1 over 2. Now the vector b, let's have a look at that one. So from the start, obviously it's going downwards, this one as shown by the arrow. That's going to go across 1, so a positive 1, and then it goes down by 3, so that'll be negative 3. So the vector b, if we write that in, b is equal to 1 over minus 3. So now we've established that, we can just treat that like we did in those earlier questions. We're going to do an a, and we're going to add to that 2 b's. So in terms of writing this one out, we've got a, which is 1 over 2, and we're going to add to that 2 of the b's, so that's going to be 2 lots of 1 on the top, which is 2, and 2 lots of minus 3 on the bottom, which is minus 6. There we go, and we can add those together, so 1 plus 2 on the top gives us 3, and then 2 add negative 6 on the bottom. Well, when we add negative, that's going to take that away, so that'll be minus 4 on the bottom. So our final vector will be 3 over negative 4. And there we go, that's how we're going to approach these vectors when they're on a graph. Obviously we can just turn the vector into a column vector and treat it just like we did on the previous questions.
This question says, the table shows the information about the height of 60 plants, and then it gives us all these classes or groups on the left. I'm going to refer to them as classes, being this 20 to 30, and it gives us the frequency within each of those categories. And it says draw a frequency polygon to show this information. Okay, now it's really nice and simple for us to do. We've got all the frequencies given to us that we're going to plot along the y-axis there where it says frequency. We just need to obviously determine where we're actually going to plot that for the heights down the bottom. Now because we don't actually know any of the heights, we know that there are 8 that are between 20 and 30, but we don't actually know what the height of any of those plants are. So what we do is we just take an estimate of those plants, and to do that we just use the midpoint between the two numbers. So in that first class, that first category, the start is 20 and the end is 30, and the midpoint of that is 25. Okay, in between 20 and 30. If you're not sure on finding the midpoint, you can add those two numbers together, so 20 plus 30 and divide it by 2, and you get 25 there. Okay, so you always have that option if you can't spot the number in between. For the next one, it's between 30 and 40, so that's 35. And then we've just got 45, 55 and 65, just double check that you are getting those midpoints correct. Now it's easy enough if we just plot those midpoints against these frequencies. So looking at your table, and you've just got to be very careful here that you check the scale. From 20 to 30 goes up 10 squares, so each square is 1. And going up there, 0 to 10 is also 10 squares, so each square is 1. But let's have a look. 25 in the middle up to 8, and as accurately as you can, that goes there. 35 up to 13 goes here. 45 up to 25, that's going to be there. And then we've got 55 up to 10, which is there, and 65 up to 4. There we go. And all you need to do, ruler and pencil, first point to second point, second to third, third to fourth, and then fourth to fifth, making sure they're nice straight lines with a ruler and a pencil. And that's how you draw a frequency polygon.
Now histograms is interesting because it's actually very, very simple, but it's quite a high graded topic in the GCSE. And actually all we're really going to be doing is looking at the area of different rectangles. I'm going to explain why. Okay, this whole topic can just be looked at in terms of rectangles. Now when it comes to a histogram, obviously it looks in a similar, I don't want to say this, but it looks similar to how a bar chart looks in the sense that we have bars, but we have bars of different widths, and the bars are actually touching rather than having gaps in between them. So it's obviously very, very different to a bar chart, but in terms of the way it looks, you know, if you're looking at one from a distance, it looks in a similar sort of manner to one. Okay, so what we're going to have a look at is actually how we go about drawing these bars, and also how it does actually differ from a bar chart along the way. Now when we're doing this, firstly we've got data which isn't just categories. Okay, we haven't got categories of data. We've got this one here which is about speed of something, and it's got a range of data, or grouped data it's called. So this first one here, if I point an arrow to it, is 60 to 65 kilometers per hour, and it says there's 15 of those. Obviously there would be a story backing up all these questions, but I've just shortened it right down just to have a look at just the maths behind the actual numbers and how we go about drawing them. But that little group there goes from 60 to 65. Now that tells us what the width of our bar is going to be, and we call this, give it a special name, we call it the class width. Okay, the class width. Now a class is just another word for group, so it's just the group width, but we call it the class width when we're talking about these. So the width of the first bar is going to be from 60 to 65, and if we have a look at that down the bottom here on my graph, that's going to go from 60 at the start along there to 65, and we're going to have a bar that's going up here somewhere, and it's going to look something like that if I draw it in really rubbishy. But let's have a look. All we now have to do is work out how high that bar is going to go. Now the height of the bar is what we have to work out, okay, and that's what we're going to be spending the majority of the video looking at. But this frequency here of 15 is going to be the area of the bar. Now the reason behind this is because all the bars are different widths, so we can't just have a little height going on, because all the bars would be you know, completely different widths. So when it comes to a histogram, well, it's actually the area of the bar is the frequency. And if we think about what that means in terms of a rectangle, if I have a rectangle, okay, and the base is 5 and the area of it is 15, what's the height going to be? And hopefully you're automatically saying 3 there. Now what you could do, obviously the mathematics behind it, is we can think of, we would do the area, which is 15, and we would divide it by the width, which is 5, and it would give us our height there, which is 3, and that's going to be the height of the rectangle. Now all of histograms basically comes down to this simple concept here, and that is just finding out the height of a rectangle. So we've got all of our areas there in the box, we've got all of our widths shown there, where I've shown the class width from 60 to 65 is a width of 5, the area is 15, therefore the height must be 3. And all we're going to do is we're going to take this approach throughout all of these questions actually. But there is a formula behind that, because obviously the width there was called the class width, the area there is called the frequency, and the height, which we're going to work out, has its own fancy name, and it's called frequency density. Again, I'm going to label that along the side of the graph here, it's frequency density. Okay, so frequency density, in fact I'm not going to put it there because we're going to put some numbers at the side, but we've got frequency, there we go, density. Okay, and that's basically just a bit of terminology there that we're going to use in order to establish the height of each bar there. Okay, what's the frequency and how dense the bars are. Now let's have a look at what this actually means then. So if we've got a height of 3, I'm not going to put that scale on straight away, because I might have some bars which have higher or lower heights, and I want to figure out what the highest bar is going to be so that I'm able to scale this axis. But we already know from the first one it has a height of 3, and our formula, if we put all the words together from what we've done here, if you think about what we did in this little scenario, the number on the top there was the frequency. So to find the frequency density, which I'm going to abbreviate here just to FD, so to find the frequency density, we're going to do the frequency, which I'm going to shorten down to FREQ so I can fit it in, and we're going to divide it by the class width, which I'm just going to write CW. So that is your important formula that you need to know. The frequency density is the frequency divided by the class width, or just thinking about the logic behind it, it's the area divided by the width, and that's going to give us the height of the rectangle. Hopefully that's a nice little explanation there that's going to help you just to understand why we draw the histograms the way that we do. So obviously over here we've done 15 divided by 5, and that gives us a height of 3. And what you can do is you can write the widths down over here if you want, just to get that out of your head so you don't have to work them all out. So if we have a look at the widths of the other bars, we've got 65 to 70, and that is a width of 5. We've got 70 to 80, and that's a width of 10. And we've got 80 to 100, and that is a width of 20. And that's how wide our bars are going to be going along this histogram here. So if I do the next one, then we've got 25. And we're going to divide that by 5, and I'll highlight them as I go. So 25, if we divide that by 5, the width of the bottom, we're going to get a height of 5 there. So good job we didn't plot that, because we've got a higher bar. The next one, we've got 36, and that's going to be divided by 10. So that's going to be 3.6. And again, a lot of these are calculator questions, but they may not be. This particular question might not be a calculator question. It will be quite nasty with this last one, but I'm going to be using a calculator throughout these questions. So the next one there, 24 divided by 20. 24 divided by 20, not actually too bad, it's 1.2. There we are, so 1.2. And there are all our frequency densities. Now if the question's particularly nasty, it won't label the axes, it won't put the scale on for you, and you're going to have to do that yourself. So this is obviously not the nicest one to do on the screen here, but obviously hopefully you've got the sheet, or you're happy just to do this sort of following along, and you've got quite a large screen looking at it. But what I'm going to do is I'm just going to count up every 10 little squares and hope that that works out as a scale, but I'm going to test it out first. So I'm going to always start down at 0. I'm just going to count up 10 squares, so 3, 4, 5, 3, 4, 5. Hopefully I get this right. There we go. So let's say that's 1. Obviously I would do this in pencil if I had it on paper, just to test it out to start with. Now if I go up another 10 squares, that gets me to here, so that's 2. Looking at it, it looks like it's going to be okay getting myself to 5. And you can see some of them are slightly darker on this, so that's 3, that's 4, and then 5 there at the top. And again, you could make it smaller if you want, but I try and make it as big as I can, just so it's not too difficult to read. Obviously the little squares there, which can be quite nasty to read sometimes. So that first bar, which I'm going to try my best to draw in with a nice straight line, goes from 60 to 65, which I've already drawn in down the bottom, and then it goes up with a height of 3. There we go, I'll try and draw that as best as I can. There we go. So there's my first bar. Now the next one goes from 65 to 70, so that's going to go along the bottom here, so it's going to be the same width, but that one goes up to 5. So again, I'll try and draw it in as best as I can. Obviously using a ruler and a pencil for these. That last little bit wasn't very good, let's just do that again. Alright, there we go. Not sure that's much better, but there we go. You get the point there. Obviously a height of 5 there, and actually a width of 5 down the bottom as well. So the next one goes from 70 to 80. Let's draw the base in. It goes from 70 across to 80, and this one has a height of 3.6. So you've got to be very careful here, because obviously 3 is going to get me up to that height there. I need to count up very carefully. So 1, 2, 3, 4, 5, 6. It's going to go to that height there, and obviously joining that up with a ruler and a pencil. There we are, there's your height of 3.6. And then we've got the last one that has a height of 1.2, and that goes from 80 all the way across to 100. And that has a height of 1.2, so where's 1? 1 is there, and then 0.2 is there. So joining that up nice and carefully. And there you go, there's your histogram finished. Okay, so it should look something like that. And obviously, you can see what I mean by the way that it kind of looks similar to a bar chart, but obviously a bar chart has gaps in between the bars, and the bars are not different widths. And here with our histogram, the bars are different widths due to those class widths. And we obviously connect it all together, because as one ends at 65, the other then continues from 65, so they're all connected and squashed up together. Okay, but that's how you draw a histogram. So I'm not going to go over any more there. You just need to make sure you remember the formula, which is frequency density is frequency over class width. Obviously, if you don't like thinking the formula method, obviously you need to know the word frequency density to label your axes if you have to do that, but you can always just think of it in terms of a rectangle. You know the area there, which is given to you in the frequency. I'm going to label that here, look, area. And as long as you know the area of the rectangle, you've got the width there. All you're actually trying to do is find the height of that rectangle. So this question says 30 animals weigh between 50 to 65 kilograms. Estimate how many animals weigh more than, and we've got 80 kilograms and 90 kilograms. Now if I have a look, we've got a histogram drawn for us, but we've not got the frequency densities labelled. So again, we've got a similar process here because we've got one bar that we can definitely link together, and it gives us that information just up here in the words. So it says 30 animals weigh between 50 and 65. Now the bar that's 50 to 65 is this one here. So in total, that has an area of 30 or 30 animals. Okay, so we can work something out from that. We can work out what the height of that bar must be. If it's got an area of 30 and it goes from 50 to 65, that is a length there, or a width of 15, a class width of 15. So the height of that must be 2. Okay, 30 divided by 15 is 2. So that must have a height of 2 just there, and that's going to help us now to scale this. And if we have a look, obviously it starts down at 0, and that's 10 squares going up to 2, so every 5 is 1. So I can scale this up now. So let's just have a look at scaling this up. So 3, 4, 5, 6, 7, 8. That's the highest bar, so I won't go any higher. There we go, we've got a frequency density of 8 at the top there. Now what I can do now is I can start to just write the frequencies within all of these bars. The next one has a width of 5. So it has a width of 5 and it has a height of 6. Just having a look at the numbers obviously just to the side here, height of 6. So that one as well has a frequency of 30. So there we go, 30. The next one has a width of 5, I'm going to write that down the bottom, and that has a height of 8. 8 times 5 is 40, so I can write that in, 40. The next one has a height of 4, and it has a width of 10. So 4 times 10 is 40. And then the final bar there has a height of 1, and it has a width of 15. So 1 times 15 is 15. Right, now that information is going to help us now to estimate how many animals weigh more than a certain amount. Okay, now we didn't actually have to do all that information, but it's just thinking about obviously using some of that knowledge that we got from the previous question on how we do that just without the table, and just thinking about it in terms of rectangles. Now in terms of how many animals weigh more than 80, what we're going to do is I'm just going to have a look at where that is. So I'm going to get rid of all these widths down the bottom. So 80 is obviously down here. That's in the middle of a bar, and if I was to split that up and draw a little dotted line through this bar, there we go, that would perfectly split that bar in half. Now at the moment we've got 40 in that bar. Now the reason it says the word estimate is because obviously we don't actually know how many people or how many animals or whatever it's talking about is actually in this bar. Now we know there's 40 there in total, so we would estimate that if we're going to split it in half, that there would be 20 in each half. So if I just write that out, 20 in each half, that would be a fair estimate. Obviously we don't know because it's group data, they could all be less than 80 in that bar. Just depends on what they, obviously that category there is 75, it looks like, yeah, 75 to 85, so they could all be, you know, 74. But we can make a fair estimate and say, well, look, we'll 50-50 split it half and half. So in terms of how many animals weigh more than 80, we've got the 20 here, and we've got the 15 here, and in total that's 35. So we'd get an answer for that. We could say 20 plus 15, which gives us an answer of 35. And that would be a fair estimate there that we can make. We know there's 15 that are above 85, but taking our little guess there, a little split of that bar, 20, 20, gives us that 20 and 15. The next question says estimate how many animals weigh more than 90. Now, if I just get rid of some of this working out here, let's just get rid of this 15, and let's just label that. So 15 in total for this bar, but 90 is just here. Now thinking about the size of this bar here, it goes 85, 90, 95, 100. So if I was to split that up in terms of every 5, look, that would split it into 3 sections. Now again, we could estimate in these 3 sections that each section had 5 in. If there's 15 in total, each section would be a fair guess to say there's 5 in each. So above 90, which is where we're looking at the moment, there's 2 of those sections. You've got 2 of those 5 sections there, and 5 and 5 makes a total of 10. So it would be a fair estimate for us to say, let's just make sure that's drawn in a little bit better. Let's put it there. There we go. It would be a fair estimate to say 10 weighed more than 90. Just thinking about how you could split that bar up. Okay, so that's something a little bit different as well. Obviously just thinking about a histogram without a table and particular questions, but that is the end of histograms and different little things to be thinking about. So with a dependent event, it means that the second event that we're looking at is going to be dependent on what happens in the first event. So
Different to the first video on this, on independent events, where nothing seems to change, in this type of question, something is going to change on that second event, and we're going to have a look at what that second event is based on the question. Now, there's loads of different types of questions that you can have on this, and this is purely sort of looking at these particular type of questions, but there are certain other questions that we could have as well, and I may have a look at some different ones in a few different videos, but I'm going to focus on these as they seem to be the ones that people struggle with the most, where we've got counters and they're not being replaced, and we're going to discuss the language just there as we get to it. So this one says, James has a bag of counters. It says, in the bag there are 5 red counters and 3 blue counters. James takes at random a counter from the bag and notes its colour. He does not put the counter back in the bag, and I just want to emphasise that he does not put the counter back in the bag, because that there is what tells us this is a dependent event, okay? And we'll have a look at how it affects it a little bit later on as we get there. It says, he then takes at random a second counter and work out the probability that James takes 2 different coloured counters. And again, obviously we need to be careful with the language there for that last little bit. James takes 2 different coloured counters, so I'm just going to highlight that as well. Okay, obviously do check out the previous video. We discussed a little bit more of the language and on actually working out the probability roots in that. I'm going to assume that we're a little bit more clued up on the actual question there from the previous video. So he does not put a counter back in the bag. Let's have a look then. So the first pick that he's going to take out, he has a red or a blue as his options. Okay, so there are 5 red and 3 blue, and if we add those together again, 5 plus 3 equals 8, so it's out of 8 counters. So we have 5 that are red out of 8 and 3 that are blue, and again that's out of 8, and this is going to represent the first pick, which I'm just going to highlight as there as being the first. Now we have 2 different options here. I'm going to draw a little picture. Now if I just imagine we've got 5 red, so 1, 2, 3, 4 and 5, and that there are then 3 blue. Let's colour that in as well, so 1, 2, 3. Now obviously we have this little option here. Let's just draw this little picture like I've done before. So we have a little option, we've got a little person at the front, my amazing little drawing here, there we go. So we've got a little person, he goes up the red route and he ends up here. Okay, now what is this option for the second pick now the counter's not replaced? Now if I just cross one of them out, let's have a look, let's get rid of this red one here. So that red one's gone. Now what is the probability of taking a red or a blue? Well, clearly one of the counters is gone, so it's definitely going to be out of 7. So let's just have a look at the 2 options that we have on this part of the tree. So the second option. Now it's out of 7 because one of the counters is gone, so we can put both of these are going to be out of 7. Let's make sure we label it red and blue. And if we have a look over here at the diagram, look, there are 4 red counters left, so it's going to be 4 reds. And that would make sense if he takes out a red, that red would go from 5 down to 4. And obviously a blue hasn't been taken out, and you can see, obviously there's still 3 blues here, so it's going to be 3 blues. Obviously those numerators have to add up to 7, and 4 and 3 do, they add up to 7, so that's absolutely fine. Now let's just restart. So we've figured out that part of the tree if he takes a red, so let's go back to the start of this little story here. We'll get rid of all of this, and we'll imagine now that instead we've taken out a blue. So let's cross out a blue, blue's gone, and now we're down here on this part of the tree figuring out what we're going to take on this next one. So what are our 2 probabilities? Now this time again, let's label it all up, red and blue. This part of the tree is not going to be the same, so different to some of those independent events, this part of the tree is going to change. Now if a blue's gone, having a look at our diagram now, we've still got 5 reds. So we've got 5, again out of 7 because one of them's gone, but now we've only got 2 blues because one of those blues is gone. That would make sense that the blues would drop down from 3 to 2. So that's going to be 2 out of 7. There we go. And that is our tree there constructed, and now we can use that to work out our probabilities. Let's just get rid of all these little drawings that I've done with my little people. There we go. Right. Let's get rid of that and put that back in. Now you don't have to use this little diagram, this little visual idea of the counters, but if you do struggle with these, it can just be a helpful way just to visualise it. But I'm going to get rid of those now because we're going to do the maths behind it. Now, looking at the roots, it says 2 different colours. So we have 2 options again there. We could have a red and then a blue, and that goes through 5/8 and 3/7. So again, we're going to multiply those together. So 5/8 multiplied by 3/7 gives us 15 on the top and 56 on the bottom, 8 times 7. Then we also have another route that we can go through. So if I swap colours for that, we could have a blue, and then we could have a red, and again that's going to be the 3/8 there, multiplied by the 5/7 on that second branch, and that again gives us 15, and it again gives us out a 56 there. So there's our two probabilities. Obviously, when we've got two that we need to combine for these different colours, we're going to add those two together. So just make sure that you add those two together carefully, write your working out down. So 15 over 56, add another 15 over 56, and in total that gives us 30 on the top out of 56, and there is our total probability of getting different colours there. 30 different options of doing that out of a total or potential 56 different ways of picking these counters out. Okay, so we're going to have a look at this question here, and it says there are some green counters and some blue counters in a bag. It says the ratio of green to red is 4:1. One counter is removed, not replaced, and a second counter is taken, and that's quite key there that it's not replaced. It says the probability that they're both green is 22 over 35. How many counters were in the bag before any were removed? So if we start to construct a probability tree here, and we have a look at the probability of green and blue. Now we only know the ratio there, we don't actually know how many are in there. So if we have a look at this as a ratio, we've got green to blue, and it's 4:1. We don't know how many lots of 4 and how many lots of 1, so we can allocate some algebra to this. We can say it's 4x, 4 lots of a number, and 1 lot of a number, 1x. So if I actually start writing this as a probability, I first need to know what my denominator is going to be. So add these both together, and we have 5 lots of x as our total amount of counters there. And now we can construct these two fractions. So green is the 4x out of a total of 5x, and blue is going to be the 1x. Let's remove the 1 there, and that is again out of 5x. We actually don't need to construct the full part of the tree here, because what we're actually interested in is the probability of them both being green. So really only need to look at the up part of the tree for this option here, where it's going to be green green, but I'm going to go about constructing all the tree to start with anyway. Okay, I do think it's important that you're able to construct these and create these expressions, so I'm going to label this up green and blue, and we'll just think about what all these probabilities are going to be. Now if I take away one of the greens, I've got 4x, and I'm going to take away one of them. So I'm going to go 4x minus 1, and on the bottom I'm going to have 5x again, taking away one counter because one of them has not been replaced. Now they're the two that we're actually interested in, but we could go about constructing the ones below. So blue would be the 1x, again over 5x minus 1. And moving down here, so let's write that in. I'm going to get rid of this in a sec, but it'll be x over 5x minus 1 again. If we took a blue out, the blue would go down to x minus 1, and that'd be over 5x minus 1. And the green above that would stay the same, so it'd be 4x, and it'd be over 5x minus 1. So I mean that's all the potential branches that we could have, but again we are only actually considering the green option here, because we've been given the probability of green. So if I went up the green and up another green here, we would go through those two fractions and they would equal 22 over 35. Okay, now what I'm going to do is I'm just going to get rid of the rest of the tree, because that's all we're really concerned about. You can save yourself a lot of time here just by constructing part of it, but it's good to be able to construct the entire tree there and think about what you'd actually get. Now if we do get rid of all of that, obviously when we're going across a tree we multiply, so we need to multiply these two fractions together. So we have 4x over 5x, and that is going to multiply by 4x minus 1 over 5x minus 1. There we go, and again that is going to equal 22 over 35, but before I set it equal to 22 over 35 I'm just going to work this out. So on the top we have 4x multiplied by the 4x minus 1. 4x times 4x is 16x squared, and 4x times negative 1 is negative 4x. Okay, just multiplying the top there just like a single bracket. And on the bottom we've got 5x times the 5x, which is 25x squared, and 5x times the negative 1, which is negative 5x. And then now that equals 22 over 35. So what we've got is we've got a fraction on both sides of our equation, and in order to remove the denominators from both sides we're going to cross multiply. So I'm going to times both sides by 35, which is going to move 35 up to the top here. I'm going to times both sides by this 25x squared minus 5x, which is going to move that to up to the numerator over here. And if I write that all out in one step, we have 35 lots of the left numerator. So we have 35 lots of 16x squared minus 4x, and that now equals 22 lots of the 25x squared minus the 5x. Okay, so I've just cross multiplied there just so I've got a single line equation. Now what I want to do is actually just remove these brackets. So I've got some quite big numbers in here. The one you're going to do is not so big, but if I actually multiply these brackets out, 35 times 16 gives me 560 x squared minus 4 lots of 35, which is 140, so minus 140x. Oh, there we go, 140x. And that equals 22 times 25, which is 550x squared, minus 22 times 5, which is 110x. There we go. Now we can actually rearrange this so we can get the everything on one side. So we've set it equal to 0. So if I subtract 550x squared from both sides, I end up with 10x squared over here. And if I add 110x to both sides to get rid of that negative 110 on the right, if I add it to negative 140, I get negative 30x, and that equals 0. Okay, now it equals 0. We're just solving a quadratic here. So there's a couple of ways you can go about it. You can solve it as it is, or we can simplify it first. I'm going to divide both sides by 10. So if I divide everything by 10, we get x squared minus 3x equals 0. And I'm going to just remove some of this working out here. So hopefully you've written this down. I'm going to remove this, get rid of this, and just bring that up here. So at the moment we have x squared minus 3x equaling 0. Now whenever we're solving a quadratic here, we need to factorise it. This doesn't factorise into a double bracket, but we can factorise x out. So we have x brackets x minus 3 equals 0. And we have our two solutions here. We've got the one in the bracket, which is x equaling positive 3, not the negative 3. And on the outside here, we've got x equaling 0. So we've got two answers, we've got to decide which one it is. Now x in our case here is an amount of counters, and we can't have 0 counters, so it has to be the positive value there. Obviously other than the 0, we can't have 0 amounts of counters, so 3 lots of the x value there. So x is 3, and it says how many counters were in the bag before any were removed. Well, if we look back at this original statement here that we made, we said there were 5 x counters, or 5 lots of this x. So 5 times 3, there we go, would tell us that there were 15 counters in the bag. Okay, it might have asked us how many green, in which case it'd be 4 times 3, or 12 greens, and 1 times 3 for the blue, or the 3 blues. Okay, so we've got 15 counters in the bag, and that's the end of the question there. So you have to construct your two branches of the tree using expressions, times them together, so you've got some algebraic fractions, creating your two fractions either side of the equal sign. We had to cross multiply to make it a single line equation, expanded it all out, made it equal 0, solved it, and then applied our solution to the question. So as you can see, a lot of maths going on there. Okay, so that is the end of this video looking at the paper 3 topics. Hopefully you found that useful and helpful. If you did, don't forget to like, don't forget to comment, don't forget to subscribe for all the upcoming videos. Don't forget to access everything in the description so you can download all of these files and practice papers and everything. And if this is the last paper that you're going to be looking through, I wish you the best of luck on your exams, and hopefully see you on the next video.